out-of-class activities. And using those solutions, we started developing various technologies that are helping us in being effective in the main dimension, in the core business of ours. I think my time should be over. Well, yes, I would indeed like to bridge what you have said, and you have already commented to Alexander Evgenievich that education is very important. Because we are looking at high schools that in ecological education, that is a priority. Then at an older age, following technological norms, following standards is another important component. So we have that in place. And 5-6 years ago, I was shooting a movie about environmental programs in oil and gas sector, and I was surprised to hear there that environment-oriented programs are present at every stage, be it at extraction, be it at processing. Even oil and oil product transportation leads us to the fact that of developing respective programs, lowering the burden on the surrounding environment. In that sense, we would be happy to hear Mikhail Yuryevich on what you are doing in this dimension, in particular at Sibur. Mr. President of Tatarstan, Rustam Minikhanov, dear guest participant, listening to what you said, I have to admit that Sibur is not processing oil, but we are processing gas and oil processing products. But otherwise, we are quite a reliable partner for oil and gas industry, for all those who are doing transportation thereof. And be it adjacent gas, be it various hydrocarbons, stable gas or naphtha, and heavy fractures, post-processing of oil condensate, that's where we work. Every presenter here, especially last two representatives of Gazprom and Tatneft, have said, and I would reiterate, responsible management, not following the fads, but relying on reasonable operations, effective approaches. In that sense, we are clearly not newbies in our industry. We are in chemical industry. On top of these segments of the colleges, the greens, etc., we also have a number of phobias about plastic bags and plastic bottles. And all the discussions about the centers of responsibility for plastic mounds in the ocean, where is that standing with? Is that with the producers of plastic, or is it with somebody else? I can't be speaking about decades ago, but maybe some 15 years ago or so, when we were doing the pilot projects in the framework of Kyoto Protocol, we have been doing work on that. Adjacent oil gas processing 23 billion cubic meters a year, serving as a reliable partner for many players around Russia, being an important player at the value creation chain, working with the adjacent product that is coming out of operations for our colleagues. We are not only part of the value creation chain, but we are also removing millions of tons of CO2 in the process of our operations. And to avoid reiterating my colleagues, what they have spoken in detail. There are three groups of where we work. First is responsible economic activity, as questions related to the development of waste treatment solutions, and obviously regulator is there. And environmental norms have become significantly more rigid in our country by a factor of times. And the development of technologies, the law on best available technologies, and the fines that are very much motivating enterprises to assure effective and secure operations. Another edge will be technologies that are helping us to become effective, and Sibur is well known for over a dozen of new infrastructure sites for processing, be it gas, be it working on different polymers, and in the framework of respective investment program decisions are very much oriented at the best available technologies, such as closed cycle technologies, respective burners, etc. All those elements are considered at the level of the even investment idea. And the third edge, something touched by Tatneft, adding to the statement of the colleague of State Duma that respective trends is a lot of just fat talk. Our task was to make sure that we don't come up with something that would just sound nice, but make sure that every word of ours would give a reliable achievement. In that sense, we have started developing volunteering movement, developing the so-called carbon burial grounds. 2 out of 10 in Tyumen, Voronezh Oblast were developed by Sibur. In every spring, we are planting trees, over 150,000 new trees every year. In that sense, it's a level of work which might sound tactical, but it helps us to avoid burying hard waste, lower our influence on the atmosphere as well as on hydrosphere. And the role of the state's participation is not only the stick policy, such with fines. We at the same time are working in the framework of carrots, working with respective developers, jointly developing mid and long-term programs, which gives certain assurances and understanding for the state as well as certainty for us. For example, this year when we have come to work in this region just 9 months ago, we have signed a similar agreement on Kazanok Synthos, which we believe makes our work more effective and efficient and make the world a safer and more pleasant place to live. Despite the fact that no, we are not going back into Stone Age, we continue offering new modern products. Yes, right, not everything that is useful is safe, and not everything that is safe is always useful. Talking about the education and raising, we hear that there are fines, there are various other measures. But you know what, you can't have it carrots only. Well, we are in Tatarstan. Ethnically, I'm not ethnic Russian myself, and it's nice to boast here. For example, the mayor of Kazan said that they have developed some solution with the sedimentation in the water bodies. They have developed some program on respective improvements. We've spoke with the mayor, we read in the newspapers, and right now we are doing similar work now at the industrial site in Nizhnekamsk near Kama River. And in the format of the event, we are having the oil and gas and chemistry forum. We'll be having this today. After lunch, we will be listening to our Chinese colleague. It will be very curious to see the experience of China, what they used to have, and what the situation is taking place today. We would be very happy to listen to Mr. Gao Xixiang. This is the Director General of Energy Research Institute. We'll do that after lunch, let me remind. Mr. President, let us draw some conclusions on what was said above. The players of the fuel and energy complex are present in Russia, and they have talked about this. We understood some things. Could you please draw some conclusions for the discussion? Thank you very much. We actually felt there is something against us in this decarbonization movement, and I purposefully requested to see the presentation to make sure that we understand what were the goals and objectives of our colleagues. The decarbonization itself is the correct dimension, just like we are talking about gas, fuel. What we are talking about lowering the temperature for the use of effective insulation materials, etc., etc. All of that would help us to lower exhaust. But when our partners are trying to make sure that their green economy is running at the expense of other countries, that's clearly inappropriate. In that sense, just like you said, we are very much interested in the approach of our Chinese partners. We are very honored to have to our partners excellencies, ministers from the Kingdom of Bahrain and the United Arab Emirates. The topic is quite appropriate, and the moderator ended up being quite effective. Let us give a round of applause to the moderator. Thank you. Thank you very much, Mr. President. Discussions would continue today. Look, I have 3 sheets of paper. These are just names and surnames of respective scientists and scholars, recognized experts in oil, gas, and chemistry industry that would be happy to share with us on the development of the energy sector. And what's important is that it would have also representatives of international community. I have enumerated the countries that are taking part in our discussion at the very beginning. So you now see the number of specialists, the countries representing. Everybody has something to say. Let me reiterate our gratitude to Tatneft, Burak, Academy of Sciences of the Republic of Tatarstan, as well as small oil companies that are showing interest in our topics. Dear colleagues, we will be meeting you quite soon after lunch. Thank you.
A little bit, and I would like to tell you a little bit more how we are going to work. And Gennady Shmal, and I am Dmitry Shugarev, and we will be listening to you from here, and everything which we're going to hear from our presentations and from the specialists from the industry. So you will have 15 minutes for every presentation. We have a lot of time. And all of you who wanted to present, I would like all of you to stay within the 15 minutes time limit, just to follow schedule, because some of you have to catch a plane, and some of you have other presentations, and we will do all our best in order to stay within the pre-planned schedule. Gennady, would you like to say anything? Something? Well, I would like to greet all of you, because we have not many people here, but it always happens after plenary, and I think that the topic that we would like to discuss is very important, and those presentations which you're going to have, they can give us a lot of food for thought, food for discussions, and especially if we have some more time, we can exchange opinions. And I would like to start now, because our first presentation which we have, which is the climatic agenda, and we're talking now about 2022, and the presentation will be from academician Shirov. Is he with us? So let me greet you, and this is the round of applause for the presenter. Could you please switch on the mic? Good afternoon, dear colleagues, and this is our joint presentation of me and the Institute of academician Porfiryev, and in this presentation we would like to show you how the situation is changing from the viewpoint of climatic agenda and from the viewpoint of its contribution to middle term and long-term prospects in our country. I think that many of you saw that yesterday we had a strategic session in our government, when we discussed the strategy of the development of the Russian economy until 2030. And the main idea of this discussion is that during sanctions, and when we see the external situation is getting worse, so we have to provide normal development for our economy. And normal development is the growth of the well-being of our people. And we have to understand how we'll use our natural resources and how this climatic agenda and what we're going to do during our first session, how they will impact on our economic development. So this slide shows, as you see, changes with the consumption of the energy in the world in the next 10-15 years. And it's clear that here we have some key tendencies which we see, and the demand on coal will decline. It will be replaced by gas, and we will see the growth of the energy efficiency, and that means that gradually the energy consumption will decrease in developed countries. So that's why in these conditions we have to use this situation in order to transform our economy, and those income which we get from selling energy resources, we have to invest this money into a modernization of our economy. The problem of Russian economy is that we cannot consider oil and gas as the key factors for our development. Well, this slide you have seen many times, but export of carbohydrates is hydrocarbons. It's just like that, and so you can clearly see the situation on the slide. So it just tells us that we just cannot consider the export of petrochemicals as the motor of our economy. So the money which we get from this industry and its distribution, this is our foundation, but as for development, we have to use different mechanisms, and this is important. So as for the world situation, so unfortunately, we are in the point of world economy development that the disbalance in the markets caused by what we saw during pandemic spread and the fact what we see this year, it all led to the fact that energy prices got out of control of the governments of many countries in the world. Well, that means that this factor of the high prices for energy, and we talked today about it, and unfortunately, this is kind of a extra weight, extra load on our economy. And this world global recession, together with the sanctions, so these are two factors which will have a negative impact on our economy. And that's, as you know, many experts said already, Russia is on the receiving end on this chain of sanctions. And so that is why we will be the one who will get the negative consequence. A lot of countries will refuse from import from our country. And this is the big crisis, a global crisis. We see that the oil cases when the share of the prices for energy to GDP more than 10%, they all led to the global recessions in the world economy. So you can see it on the slide. And it's clear that the additional pressure is caused by the situation which we see in the European Union, which is trying to refuse from Russian energy resources, oil and gas resources. And of course, it just decreases the situation even, it worsens the situation even more. And in European countries, for example, you see that their GDP is getting down 1.2%. And the next factor is Russian economy. When we look at the goals of decarbonization and try to see how we can develop, we have to understand in what parameters of this energy consumption decrease we can afford. And so there are some points in this different documents where the dependence on well, some indicators which we see in the statistics, they show that our economy must develop through cooperation with some other partners, and probably we will not be able to reach this goal. For us, the level of 0.5 is probably this is the indicator which we have to keep in mind, and to think about the extra optimistic scenario, while it's very harmful because it can lead to unfounded requirements to business, and we understand that we will need more energy for our development. So what else is more important? A lot of people think that this decarbonization is some kind of response to what is done in the global economy, in European economy, some kind of defense strategy. But our analysis shows that in all leading sectors of Russian economy, decrease of energy consumption and the decrease of the greenhouse emission. It's all connected with investment into the main capital. And so, of course, we decrease the level of carbon consumption, and of course the quality of using the primary resources, and doing this we get to the reach the goal of increasing the competitiveness of our economy. And now we'll talk briefly about how we see the current situation and how we and here we see our last evaluations, which we what happened, how the emission can change in the Russian economy in up to 50-50, and we see that the key sources of greenhouse gases emission decrease. It's energy. This is the utility companies. It's our pipelines, and it's the sector which in our ecosystems, it's forests, land, and so on. As for the structure which we see on the slide, we see that the industries as impact is not very significant. Well, that means that the main efforts must be where? Well, modernizing our energy sector, and most is our utility industry, so increasing the comfort of places where we live. This is the modernization of the construction rules and regulations, administrations of the new standards in construction. It's all will make our life better, irrespectively to what's going on with the climate agenda, so we have to do it. So these are all things which are connected with such things that, for example, so the company must be more careful about how they store oil and gas, how they use it. It is for all our ecosystem. It's all a big question to our science because we have very vague ideas about how our nature works, how our nature traps carbon, and we have to, through understanding how it works, we have to manage this ecosystem, and this is a task of the science and industry, and as we see, this is the highest potential. And as for the technologies, we talk about technologies and the utilitarian sense. So these are not risk-free, and all these technologies of decreasing the greenhouse emission, which we have been told a lot, it's and this technology is connected with the waste treatment, the electric transport, this trapping CO2. All of it, all of them have risks in terms of declining economy, limiting import, and so on. And here, my colleagues and I, we evaluated how these technologies are organized from the viewpoint of negative impact on economy. And so this slide tells us that Russian economy, nevertheless, still lags behind the developed economies in the world. Well, that means we have a chance to choose from huge range of solutions. So, but we have to choose solutions which, from one hand, allow us to reach goals of economic development. On the other hand, allow us to reach the goals, how to decrease greenhouse emission and some other goals. And the third is that we have to follow the minimize the risks for our economy. So main advantage is that the range to make a range of options for correct solutions is quite big. And of course, well, let's see what we have now here in the green color. This is the prognosis which was calculated for the strategy developed in 2029, one by our government before the Glasgow summit. And these are two scenarios of CO greenhouse emission changes during sanctions and while keeping these decarbonization measures into 21 strategy, or some decrease of it under the impact of some technologies, and some of them we will not have access to. What we see is that if we keep all these measures which we had in our strategy for low carbon development Russian Federation, so in spite of decrease of the economy in 2022-2023, we anyway will get same dynamics in terms of emission results. How is it possible? Well, it's very simple. On one hand, up to, for example, 2030, 35, we'll have the low emission because economy in this sanction scenario will work less efficiently. As for the after 2035, there, unfortunately, the level of emission decrease will be lower than we expected before the events of 2022, because the impact of this we see right now. If we can overcome, or if we could overcome the sanction limitations, this is the blue line on the graph, and we will have less emissions by 2050. So that means that everything which is going on one hand, does not change our goals and in terms of decarbonization, because we do it not to decrease CO2. We do it in order to live better and live a better life in a better economy, which solves the goals, solves the problems of increasing the well-being and decreasing the harmful impact on the environment, so that we can say that the strategy for low-carbon development stays as an important element of strategy in our economy. And those solutions and those decisions which are made by our government will include this approach. As for our economic operation, is that we must not refuse from participation in climate change program process, and we must not abandon the Kyoto Agreement, because this is important way to impact on solutions, not in terms of climate, but the economy as well, because climate agenda is much bigger, much more important than it used to be, because here we have things connected with the structural changes, relationship between developed and developing countries, and for us it's very important that Russia can be heard. Thank you very much, Alexander. And if you allow me to, so you gave as an example developed countries and how they progressed in technologies which meet the ESG standards, and at the same time, as I follow how the economy was developing, it's some kind of a tricky thing. I'll explain. Well, business was investing into the companies which are in the countries where it's not obligatory to use ecological standards. So they produce this emission in other countries. And let's talk about the fly in the ointment. And we just have to think about it. In order to achieve decarbonization goals, we have to follow the rules of the game. Yeah, I can agree with you, but we have to add that the developed countries have gone through this, went through this industrialization 50, 60 years ago. And that means that this approach impedes the development of the developing countries, which are going through this industrialization now. And it's clear that climate change agenda, it's about money, it's about world competition. And that is why we have to stay within this agenda, so that together with other developing countries like India or Kitai or China, we have to promote our agenda. And so these are a lot of countries which cannot overcome this situation without anybody's help.
And who are unfortunately forced to follow that specific scenario development that we're developing themselves using cheap paid labor, etc. Yes, let me reiterate that our task is to transform this decarbonization strategy into an active tool for modernization development of the country. I guess I have a comment here. Is how much energy does the country generate per person per year? Let me give an example of figures. 5.4 tons of oil equivalent of per year, 3.7 in Europe, similar in our case, and in Africa is 0.4. That's where we need to be investing resources that are lacking there. And this can be complemented by stating that 2 billion people in Africa don't know what is electricity, and in best case are cooking food, burning wood, the very best case. In that sense, when we are talking about the exports of ours, we need to be keeping that in mind. Europe would not be able to live and survive without our oil and gas, that's clear, but we should also effectively redirect our exports as well. Especially that lately we are having interesting statistics. Let's give an example of a mobile phone, and it was demonstrated how much of the production of a smartphone is slave labor. There are things to think about. I'm inviting us to continue our discussion, discover more about Russian strategy of energy transition, and with us is Denis Nurgaliev, Prorector of Kazan Federal University. Victor, I would like to change a little bit my presentation, but I promise to fit into allocated agenda. I didn't have a chance to be in Moscow and congratulate him personally, Vladimir Геннадий Иосифович Мессершмаль. And I actually brought a medal for you, 300th anniversary of the Russian oil. See, they exchange souvenirs on stage. That's a beautiful stone. I guess that's something from geology. My dear colleagues, we are having very interesting presentations. Some deserve discussion more than others. I would like to talk about a number of projects implemented by Kazan Federal University in this dimension. And one of them in the framework of academic leadership, Priority 2030, is called Russian Energy Transition, the Balance of the Potential and Global Trends. There are obvious trends as well as natural potential of Russia that allows us to implement that program differently. today we are talking about ESG implementation of that strategy is important. The climate is changing, and it's undisputable that we would probably have average temperature increased by 2.5–3 degrees centigrade. We are running cooperation in scientific research with the purpose of developing domestic national technology, helping us to move from hydrocarbonic economy into post-fuel economy, a post-burning fuel economy. And we are running the analysis of various databases, types of energy consumption, as well as abiding by indicators of COP. Analytics shows that the average temperature would indeed, by the end of the century, would increase by at least 2.5 degrees centigrade. And now, making forecasts is not very reliable, but it's clear that renewables by the end of the century would consist about 30 to 35. Oil and gas would stay around 50%, and everything else will be coal. The consequences of the rising temperature would start being felt by mid-century, and we have an international research team that is working on this. And we see that until mid-century, variability of the climate will be a main factor that would be leading to increasing fires, etc. And we can have great many negative factors such as melting of the permafrost, desertification, etc., etc. I'm looking at what can affect and what breakthrough negative effects can take place and what breakthroughs can we have. One breakthrough could be production of thermonuclear stations, but that would require specific materials. We don't yet have superconductivity as well as the global energy network. Well, the questions of how realistic it is to address these solutions and how much time it would require, but each of the respective technologies can affect the energy transition. But there is a real simple prospects of replacing coal and oil by natural gas. That would have a similar effect to increasing the share of renewables by 20–25%. Analysis is of the global warming is demonstrating that Russia would mainly have negative effects of the global warming, mainly touching polar regions or pre-polar regions due to the melting of the permafrost. A number of the oil and gas fields will become marine fields. Russia is not emitting CO2 much, but in a relative manner, we are leaders in that sense. Lieutenant Stanich was saying that this is actually a challenge. Our GDP has a very low carbon trace, and it's important that we would be able to follow those principles and be able to modernize our economy, transform our economy in many fields. Many of the realities we see today are shaped naturally. In the first half of the plenary, it was said that many companies are working on this. Russia is free from coal-based energy generation, something that none of the country is living today. But those trends are clear. At the same time, the world is slowly moving towards decreasing consumption of fossil fuels. We clearly see that global fossil fuel consumption cannot decrease overnight. And the problem of providing energy access cannot be resolved without cheap energy. It was already said by the number of population that has no energy access altogether. And when we are talking about developed countries, that's a small share of the global population. So we need to look at the realities of the energy generation, the global economy. Now, what should oil and gas sector be doing to address the challenges and contribute thereto? First of all, we need to continue looking for the gigantic gas fields in eastern and western Siberia for development of the infrastructure for extracting. Today, natural gas is a transition fuel for the 21st century. Interestingly, that oil and gas companies start stressing gas extraction. Plus, of course, we need to be developing more effectively mature fields that have big reserves and have necessary infrastructure of all supporting types. At the same time, extraction is decreasing, and a significant share of oil and gas is being left unextracted. And today, short term, it is more prospective development of respective technologies, and their application is a strategic priority. It is an important priority of the research center that was established at the end of 2020 in cooperation of 4 universities, and I would mention that. In the framework of this research center, I'm showing you the slide, and for the dimensions in which we are doing work, the paradigm of development of gigantic fields is being implemented today, developed at the level of the world level scientific center, and is being introduced at Ramashkina field as well as at Lashkina in Bashkiria. Another technology developed in this center is directed at the search of the gigantic fields at the shale of northern shale and Arctic. There are a number of gigantic fields visible from the reserves, and we are using various satellites as well as land-based data analysis to assess the intensity of heat flows and probable warming of the organic field, and identified locations most prospective for gas pockets in the framework of that scientific research center for the surveying, for the identifying reserves is one of the most effective, competitive with the more expensive technological solutions. And here I'm demonstrating examples of the ways we search for prospective solutions. We are among the leaders on catalytical enrichment of hydrocarbons subsoil. We are talking at in-soil catalyzer, in-soil generation of hydrogen when you cannot be developing the field because there are sedimentary left residual oils, heavy and difficult to extract, and you are using this in situ processes in order to generate hydrogen with all undesired components, things in subsoil. We are in the process of transferring respective technologies to real sector companies. That's especially important because the quality of reserves we have now is decreasing, and that would give a possibility to extract them, transforming them into hydrogen. We are developing a technology of sequestration of the hydrocarbon and CO2 in the natural reservoirs. Today we are looking at that. Very large territories of forest and water surfaces is giving us great opportunities for carbon sequestration. And we are to develop the whole network of respective carbon sequestration test beds and beds. Unfortunately, we do not almost have no analytics on various data collection as well as data analytics for respective sequestration in natural systems, and the developing of such would help us to develop that system. And the carbon test bed that our university is running in Volga region is becoming valuable in that sense. I will give you a vivid example that would help you understand how important it is, and that it's not simple, but it's quite possible. If you increase the amount of carbon in agricultural soils by 0.4, it would compensate the 35 gigatons of CO2 that is being thrown out into atmosphere. Low carbon economy would be a result of the reality when we need to lower this carbon emissions. And that challenge would open up great opportunity for Russia. And at first stage, until 2030, we believe that oil and gas field needs to develop a paradigm for the development of gigantic fields, continue searching for new gigantic fields, develop infrastructure for compressed natural gas, move to respective energy solutions, and provide our country with bio system. I hope I have fit in to allocate time frame. Yes, let's hope that the current ecological, economic, and political situation would allow us to the chance, and we'll be able to use that to be not among those catching up, but to be among equals. We have that opportunity, right? Indeed, we do hope that we'll be able to use that. Well, thank you very much. Right now, let's move on to another presentation, also on decarbonization. Is called Dialectics of Decarbonization. It's important to mention that dialectics is based on the analysis of the conflict of the opposites. We are being joined by Valery Anatolyevich Krykov from Siberian Academy of Siberian branch of the Russian Academy of Sciences. Thank you very much, dear colleagues. I'd like to thank the organizers of our conference. It's at least maybe the 10th time I'm taking part in Tatarstan oil and gas chemical forums, and it's a great pleasure to see both the conditions, the sites where these forums are being hosted, as well as the width and depth of those discussions. First, here we are having now a very practical one. It is an honor to be speaking at. I'm representing here Siberian Institute of the Russian Academy of Science on one side. Secondly, I'm chief editor of the Russia-wide Echo scientific magazine. It simplifies me very much the topic of presentation, because in the foyer on the left, when you're coming in, among the materials distributed, there was that magazine of Echo where the Uncle Frost was running behind Sustainable Development Goal number 13, Sustainable Development, Low Carbon Environment, the most comfortable environment for the people to live on our planet, which is nowadays quite a challenging environment. That's a second quality of mine. And thirdly, it's a great honor for me to be doing this in the presence of Gennady Shmal. I have spent all of my life working at the oil and gas area in Siberian Academy of Sciences, and Gennady Yosevich Shmal was the founder. He was one of the founders of the Council of Young Scientists, the Central Committee of Komsomol, and together with his colleague, they have developed the economy of oil and gas complex of Western Siberia extraction was growing very much, and they quickly have understood that oil and gas is important, but understanding how this affects overall territory or development, how this affects the dynamics of socioeconomic indicators is no less important. So it happened that I've been working on this topic for all the years. At the times when they were setting up laboratory, I was still in high school. So in that sense, Gennady Osipovich has an opportunity, has a capacity to foresee, and bring together people who understand these topics. And my presentation is a joint work of the Institute of Economy of Siberia in scientific research of geology and geophysics of mineral resources. And I would like to communicate to the audience three thoughts. First, it's not only climatic agenda, decarbonization, but sustainable socioeconomic development. What was said very much by my distinguished colleague, Alexander Zhel. Modernization of economy, that's first.
Also, we have to deal with this second. We have to look at and analyze the economic aspect. So what's going on? Because economic processes are going through time. We forget about it. We look at the prognosis, but the economic time, it is this range of time or time brackets within which different economic processes are developing. So Alexander showed us the energy output, and there are too optimistic people who don't understand what's going on in the Russian economy. You have to be realistic. And the third, so it's a role of the territories, role of the institutions, and making decision about sustainable development, including ecological sustainability, climatic sustainability. And so we have to decentralize, and we have to be more initiative from bottom up. And it's we're talking about three things which we have to organize, and I've just mentioned, we're talking about business, authorities, and society and communities. So, and here on this slide shows us this decarbonization on one hand, it's different elements, and we have positive and negative, constructive and deconstructive elements, and we have to consider them together with the sustainable development issues. One of the key problems is when we get extra profit from situation in the market like we have now, because we just pay too many dividends, too much money for dividends, and we have to use special rules and regulations and just modernize and think about modernization, think about putting economy on the modern level, and take into account this unique and potential experience which we have had in the Soviet Union. For some reason, we don't pay enough attention to Soviet Union experience, because we had powerful industrial economy, and we had a lot of new technologies, and now we have the negative results of some kind of policy. We have high tariffs. It's impossible to regulate. We have too many monopolies. And so that means that we have to take into account the realities, the awkward truth. And so that is why decarbonization and the issues which we are discussing now in our conference has to be considered within the body of a lot of issues, which you can see on this slide, which are connected with the solution key problems in the Russian economy. They are right in front of you. I will not dwell on it. And then examples of modernization and approach to solution of different kind of technical challenges for modernization. I agree completely with my colleagues from the Institute for the Prognosis. So the energy industry cannot be the driver; it can be the foundation, and but it can work only in certain kind of legal environments, not only investment credits, not only special industry privileges, It's a continuous communication between and among all interested parties. Here is one of the projects which was developed by my colleagues and geologists from the Siberian Research Institutes and connect. It's about increasing the potential of the energy system. The green energy is one of the drivers, so it consists of the number of projects. Alexander Shirov, we talked a lot about it, and we just don't know the world we live in. And now we, people who work in economy and people who just develop the ecosystems, and so we have to transform these things into something which is connected to the life of people, and that to see this possibility to live nice and comfortable life in all parts of our country. And let me just repeat myself again. So the main idea is that sustainable development, not just the strategy for sustainable green development and achieving the purposes of the green agenda. It's also the adaptation to the economic times. You have to understand what's going on, the processes. And as for the long term, as we see it, what steps we have to undertake. So this on this level, special thanks to the Ministry of Education. We, together with their institutes and departments, we developed a very big project. And you see it just in front of you, which is using the synergy of our specialists. We try to organize a platform for database in order to analyze and evaluate this interdisciplinary and inter-industry space of chains which work on adding value to the. It's not just commercial benefits. We look at this broader, and we try to look at the bigger picture. And well, thank you very much. And so this is our. We have our journals and the exhibition. I'm ready to answer your questions. Well, thank you very much for the possibilities which you gave us, and thank you very much for this. And thank you very much. And we move on to the next point. And dear colleagues, if you have questions to participants, so that is why you can ask them. Feel free to ask them during our conference. And now we move on to our presentation, the prospects of development of the Paris Agreement for the decarbonizations of the. So, Professor, first President of the Kyrgyz Republic, Askar Akayev. Well, thank you very much. Dear Gennady Vasilyevich, dear Dmitry, dear colleagues, I present Moscow State University, named after Lomonosov, and we deal with the modeling of the world dynamics, and headed by the Viktor Anton Sadovnichev, one of the famous mathematicians, and of course we work with the problems of the climate change. And as you all know, one of our main tasks in 2021 century, in the 21st century, it's dealing with the climate changes, and the Paris Agreement 2015 just elevated this goal to 1.5 degrees Celsius. A lot of people don't understand it, but can you imagine the Earth biosphere is the same sensitive to the temperature as the human body. So can you imagine your body temperature increases in 1.2 or 2 degrees? So, and so in the same way, the biosphere feels the same. And as compared to the pre-industrial revolution, the 19th century, the average temperature increased 1 degree. As by the 2018, it's proved by the very precise computations and calculations by many scientists of the world, and it's a fact. And so that is why we don't have a lot of time. We just have no more than 1 degree for the 21st century. So for the rest of the what we have, 80 years at the end of the century, we have to stabilize this growth, and we cannot go beyond 1 degree. And if we don't manage, it will give us a lot of problems. And this year shows us, we see this extremely dangerous heat waves, droughts, and in Europe, which we haven't had for 500 years. A lot of floods in Pakistan, in China. It's all because the glaciers are melting, and in Switzerland, a lot of people say that a lot of glaciers melted down completely, so the climate is changing and it's going on, and of course we have to take extreme measures in order to achieve these goals. So why we talk about 1.5 and 2 degrees? So it's a result of a lot of research work, the big international team of experts working in the area of climate change, and this group was organized by the initiative of the United Nations in 1988, in which a lot of outstanding Soviet scientists were included, mathematicians, climatologists, ocean specialists, and oceanologists, and later on Russian scientists were included as well, and among them they have Nobel Prize laureates in this area. And this goal, 2 degrees, was formulated by the European Union 25 years ago, and in 1995, and not once was supported that to increase global temperature more than 2 degrees. It's extremely dangerous. It will lead to big ecological catastrophes with unpredictable results up to the extinction of the humankind. And Paris Agreement, the historical one, 2015, so it just narrowed it down to 1.5 degrees. Well, speaking on the language of energy, the concentration of the CO2, it has also other gases, methane, for example, and many others gases, but the CO2, it's the main culprit and the guilty one for these processes, because it has the highest concentration in the Earth atmosphere. So it cannot be 550 units per million. So, but Paris Agreement sets the goal to limit within 450 particles per million. Well, to understand where we are now, so it just Not long time ago, we were informed that in 2021, we have 415 particles per million, so we're very close. And I don't think we'll be able to stabilize it on this 1.5 degrees to limit the concentration of the CO2 on the level, to get the level to the 1.5 degrees Celsius. So, what requirements we have? In order to stabilize the situation on the existing level, we have to decrease the CO2 emission in 3 times compared with the maximum level, which happened in 2019. Before pandemic, we're talking about 33 billion tons of CO2, or 3 times, or 11 billion tons. In order to stabilize on the level of 2 degrees, we have to decrease it to 14.5 gigatons. And of course, this is the extremely difficult challenge to solve, but if you try hard, it is possible. It is within the scope of our possibilities. We have enough financial, technological resources. We have enough. But to do that, we have to channel about 2% of the world GDP. So it is about 2/3 of expenses which we use for the military purposes. Of course, politicians will vote for the latter, not for the former. And this is how the Glasgow Forum shows, which was held in 2021, but the results will be tremendous. Catastrophe. This we in Moscow University we have big group, big team of interdisciplinary researchers where we have mathematicians, physicists, climatologists. I present mathematics, and we have models which allow us to modernize the global dynamics, and this is the demographical dynamics, economic dynamics, geopolitical, and in particular this the climate change. And we of course calculate the energy consumption. And here is the what we see with the energy consumption, and you see that it's like an explosion of energy consumption in the 20th century. And it's like an explosion of the demography, and you see the explosion of population growth, and economy grew 20 times, and the energy consumption, as you see, grew as well. And now we hope, and it's a reliable prognosis up to the end of the century, that to stabilize energy consumption and to decrease the CO2 emission. Yeah, we all model these things on a supercomputer. We have very good supercomputers, and we model hundreds of different scenarios during last years, and I can show you 3 of them. 3 scenarios, and here I also would like to show what we see on the top. On top, this trajectory, which all depends on the dynamics and how the people grow, and it's connected with the prognosis of the United Nations. And United Nations give the most optimistic scenario in terms of the number of people, and this thing that in 2021 population will grow up to 10 or 11 or 12 billion people. And well, we have models which show us that the population growth will not grow 9 billion, and we will grow until the middle of the century, and then it will decrease for different reasons. But the main reason now, decrease of the population, is the implementation of the intellectual machines, intelligent machines, robots with elements of artificial intelligence. They will function as people, and they will process
this energy transition. First scenario is conservative one. We are relying on scenarios that are developed by international institutions, for example, IRENA on renewable sources of energy. They are calculating great number of possible scenarios, including development in photovoltaic, oil-based generation, wind generation, etc., relying on scenarios developed by International Atomic Energy Agency, hydrogen energy. In that sense, we are not basing ourselves on scenarios taken off the top of the head, but by the scenarios, scientifically proven scenarios calculated by distinguished scientific agencies of the world. First scenario demonstrated here, we call it conservative one, developed by international agencies and organizations, the so-called blue map scenario. It was in order to stabilize the global temperature increase at the level of 2 centigrade, and we have demonstrated with computer modeling that this scenario is managing to do that. On the left, you see CO2 exhaust indicators. We are calculating trajectories of energy consumption, then the trajectory of lowering respective exhaust, and demonstrating those figures for various scenarios and various demographics around the world. The lowest one, the green one, is the scenario that we are proving, in the sense that we are believing that there is a wonderful opportunity. It's not the environment in which there is a reason for much concern. There is a possibility to address the challenges. I have already mentioned earlier that by 2018 we have already used the 1 degree. We have increased by 1 centigrade. By this scenario, it shows that we would get to about 1 more centigrade by end of the year, and you would be able to stabilize it there using all technologies, be it CO2 capture or CO2 sequestration. Something that was mentioned at the plenary. Please let me stop on the top right corner. It's in red. It's a share of oil. Western specialists believe that it should stay at a level of about 30% throughout the century. In black is oil. It should be decreasing by mid-century and go to about 10%. Lower you see it's the gas, and you please note that Western specialists in respective scenario are showing us to the desire for us to use gas and stop use it up by 1940s and stop that. The difference is that the difference in approaches of the East and the West developing and developed countries. In this sense, this is very much anti-Russian scenario directed at limiting the use of the Russian gas, and Russia has the global amount of gas field, significant share of gas fields, and we have seen that this started materializing in recent years, and especially in 2022. Plus, we see in this scenario limited use of atomic energy. We know that our Western colleagues have phobias related to nuclear energy. And now let me move with the description of ambitious scenario. And in that, natural gas is being actively consumed, used until 2070, 2080s. And in here, our Western colleagues understand that the use of natural gas can very much smooth down the processes of changes in the Earth climate. You see photovoltaics here, you see wind generation use, but we have demonstrated that this can only happen when we double the capacity of nuclear energy, because to stabilize solar and wind farms, the best ways of stabilizing unpredictable capacity of respective renewables is nuclear power stations. Small scale ones. In this sense, we should state that Rosatom is a clear world leader. First mobile nuclear station was built and introduced into operation by Rosatom a few years ago. It works in the far north. Our respective mobile, small and mid-scale, mid-power nuclear stations are very important, that could be moved to the areas of a concentration of various photovoltaic or wind generation farms, and the Western scientists are accepting this, are agreeing with that. And in case of coal, there's no disputes here. We should be getting rid of them as soon as possible. And here I wanted to reiterate, China is a global leader in the area of decreasing coal-based generation, as well as in the area of photovoltaics and wind farm generation development. Here I would like to move on to the following scenario, the so-called net zero one. Zero emissions by 2050. It's the scenario that we have published in the Energy magazine, the international one. It gives the smoothest and the most effective scenario, helping us to achieve the Paris COP agreement results. In here, you see on my slide that natural gas would be used as a source of energy until 2080s. So whenever you look with energy consumption modeling without some prejudice, you see that you just can't do it without gas. Coal is too dirty, and the gas allows smoothing this great energy transition. In this sense, Russian gas should be working. In black, I'm showing nuclear energy generation, which is important for stabilization of photovoltaic and wind farms output stabilization. And, well, oil and coal should be the consumption of respective energy sources should be decreased. It doesn't mean, though, that the role of the oil industry would be decreasing. The role of oil would only be increasing. President of Tatarstan was recalling the statement of Dmitry Mendeleev, stating that when we burn oil, it's as if heating yourself by burning banknotes. In that sense, oil industry would be very important as a source of raw materials for petrochemistry, etc. In that sense, both oil and petrochemistry are great. In that sense, we can say that oil and gas would be the very extractive industries of the 21st century for extracting important production resources. And on the top, we have demonstrated the one more scenario, which is hydrogen power generation. And when we engage hydrogen energy, that's an area where Russian scientists are one of the leaders around the world in the area of generation of hydrogen-based energy. That's when the wonderful results are being achieved. At the same time, please draw your attention to the lower left corner. This brings us to only 1.7 degrees. This is the best possible scenario because it seems that humanity lost the chance of stabilizing global warming at 1.5%. Unless, of course, all global leaders just come together tomorrow, sit down at around one common table, and just agree all together, saying that we are now accepting a mandatory program for all of humanity, for all over the world, and are working to achieve the objectives of the Paris climatic accord. In that sense, but in principle, a train have left. We didn't catch the last carriage. Our computer modeling demonstrates that 1.7 or possibly 1.6 is still theoretically possible. And in conclusion, some 15 years ago, under the leadership of academician Sadovnichi, we started reviving modeling of the respective dynamics. Back in 1990s and the beginning of 2000s, it was almost forgotten and stopped in Russia. After magnificent work done by the School of Academicians Nikita Moiseyev and Vishani, there was little work done in that dimension. Well, under the leadership of Sadovnichi, we have revived this recently, and we are competing in this. In particular, in 2014, our work was introduced into the Oxford University Handbook. It's actually it's a compilation published in the United States. A number of centers were doing this modeling. We were part of the group led by Oxford University, and our work was including there. We were shown that the objective should be increased, made more ambitious, so that we aspire to reach stabilization at 1.5%. And last year we have supplied our work and published it in the Switzerland published Energy magazine, the main magazine of the COP Accord of Paris. And well, last year we have finalized our report to the Club of Rome. In previous century, Soviet scholars presented 2 reports to the Club of Rome at the times of Решение. In 21st century, headed by academician Sadovnici, we have offered respective report to the Club of Rome on various dynamics, on demographics, on poverty, and all challenges related to global dynamics, and on how to assure survival of humanity in 21st century. The report was accepted by the Club of Rome. It's now in Switzerland. It's being published by Springer Publishing House. It will be a report dedicated to the 50th anniversary of the publication of the first distinguished report of the Club of Rome called Limits of Growth Prepared to Growth, prepared by Meadows and colleagues. And for the 50th anniversary, we have presented the report of the Russian scientists headed by Sadovnici. It was obviously discussed. There was some criticism. We have objected and justified our positions. It's now being published by Springer in Switzerland. And in conclusion, I would like to state that it was a great pleasure to be present today at the Forum of the Specialists, the workers of gas and chemical industry, which is the engine for economic development of not just Russia, but all over the world. It was said today that the coming Sunday is the special industrial holiday for the specialists of this industries, and I would like to join you in all those that have congratulated. We can only resolve the climatic challenges with your active support. Thank you very much, Skarkage, for your detailed report. And in the process, you have also responded to an important question of what the science should be doing. Should be fighting the false science. Who is bringing more CO2 into the atmosphere? Is that volcanic activity or is it human activity? You might have seen respective discussions, but obviously you cannot doubt supercomputer work. I'm very sorry. I possibly need to come closer. I don't hear very well. No, that was just a lyrics passage aside. I'm grateful for your presentation and thank you very much for being with us at now a scientific plenary. Thank you very much. I would like to add that just like everywhere in other questions, it's not appropriate to be looking for who is more guilty. It's the area in which we should come together and look for the resolution of the current challenges at hand. Clearly, developed countries should be making greater contribution because they indeed have benefited greater from the oil and gas industry over previous 2 decades of industry or revolution, and nowadays are trying to shift them into the shoulders of the developing countries. I wanted to give the figure calculated by scientists. In developed countries would have to allocate 750,000, almost millions, almost $1 billion or $1 trillion a year for the developing countries to be able to move on to the rails of green energy and economy in order to try to achieve the COP climatic agreement objectives. We would hope very much that respective funds would be allocated properly. In particular, you have mentioned the experience of China, which is one of the global leaders. As in all areas, many would agree. We would listen to a representative of China, People's Republic of China sometime later, but now we would let us listen into the presentation Technological Challenges in Petrochemistry, corresponding member of the Russian Academy of Sciences, Anton Maximov. Maybe please have a presentation demonstrated on screen. There was another component saying in conditions of decarbonization, because the presentation is relatively short.
And I would like to tell you about the view which we have in a petrochemical industry, how the oil and gas industry will change in the following 30 years by 2050. Some of what I'm going to say sounds like fantasy. Some things will be more realistic, but the petrochemical industry will be changing because of the decarbonization strategy. And decarbonization strategy, with its first consequence, resulted into electric energy. It's not heat, which we use in the combustion engines. It's not just electricity. And you get electric cars. And even if you increase the energy efficiency and decrease CO2 emission, you decrease the demand on oil and gas as fuel. And so what's going to happen with oil, and what going to do with oil? And in a number of prognoses, we think about growing demand for the gas 2028, 2030. Then the demand on the car fuel will go down. And precisely because the carbon trace will decrease. So we have to do something with oil. Traditionally, we have 7 to 10 oil of turn into the petrochemical products. And the Sibur company said that we deal with gas. It's so what you're going to do with this 90%, which is left, or will be left? So it's 10 years ago, we started changing the concept of petrochemical industry. Now we're talking about that 40–50% of all we have to process, and this first plant was already built in China. It's a mega plant. With its 14 million tons capacity. It was launched last year. It's a fantastic capacity. And these kind of technologies are now developing very quickly. A hydroconversion, which we have in Taneka, well, this is how we process oil. And this is the first impact of decarbonization. We're talking about the fact that we have to turn oil into something useful, not just burn it. Second direction is decarbonization. It's the processing of the polymeric waste. Yes, as it was mentioned in our plenary session, the problem of the polymeric waste, it's a culture problem, whether we will gather this waste. Well, part of it we can turn into plastic again, into some plastic goods with some additives, but part of it we cannot do anything. And there is one more source of raw materials for petrochemical industry. So polymeric waste. So these are technologies which are being developed very actively. Polymeric waste can be easily turned into fuel, but polyethylene you cannot into ethylene with 90% conversion. This is a problem. This is the problem which we are solving now. So this is the one of the directions of developing petrochemical industry. So the third problem is it's about using the CO2. Yes, the CO2 is energy, first of all. And for the last 20, 30 years, we can move to technology which is about trapping and burying CO2. Well, we have to do it, although decarbonization is slowing down. The last laws in the United States, they plan to spend $390 billion as a tax preferences for the next decade. And the CO2 will allow them to get 85 tax privileges. $85. So that means that we will get huge CO2 resource, and CO2 is turning into resource for petrochemical industry. Now we are developing the gas deposits, and probably we will use CO2 from the reservoirs. And there are certain ways of CO2 conversion with using the methane or hydrogen. And so this is something which can our country benefit a lot if we have these technologies. But the fact that to the left and to the right, so these are the things which will be some kind of the highway in 2030, 2040. So the plasma chemical, the chemical transformation, the CO2. And if you have cheap renewable electricity, so electricity becomes a resource which we can start using, and the industrial electrochemistry is developing very fast. And the second thing, it's of course green hydrogen. And American Inflation Reduction Act, they have just a fantastic story. This is the compensation for the for this kind of produce from $30 to $60 per kilogram, from 60 cents to $3. 60 cents is basically blue hydrogen, which you get from natural gas, and then you can use it for some other reasons. And the green hydrogen, so you see, you basically can use it as you want to. And so that is why the Taneka company is one of the companies which is very actively working in this kind of research. And in spite of the fact that the decarbonization, it's just lagging behind, but for tactical purposes, which every company has in modern conditions, it's in general, all these directions and these technologies, they stay here with us. And last slide, it's how this plant will look like in, say, 30 years. Oil becomes a main raw material. Oil becomes main raw material from viewpoint of processing, and it's almost 100% processed petrochemical product. The bio materials, polymeric waste, and we get electricity as we use it. It's not only hydrogen. This is also using electricity for heating reactors for energy, and two biggest petrochemical technologies in the world already said that in 2026, 27, they will have electropyrolysis, where they will use not burning gas but electricity. So of course it's CO2 and hydrogen plus methane, and this scheme looks very unusual, and of course we will get it not very soon. especially when we plan to use these plants for 20, 30 years, but it will be inevitable consequence of this dehydrogenation, carbonization. Paul, well, thank you very much. And among our topics which we have on the conference, we have quite a big range of different topics and views. So probably we will have the whole assortment of different kind of views and ideas on this topic, about this topic. And now let me greet online the academician Stanislav Zhukov. Do we have connection? Yes, I'm with you. Well, hello. We're very happy to hear you. Let me introduce the topic of your presentation. Correct me if I'm wrong. Decarbonization strategy of the world's largest oil and gas companies, the experience for Russia's sustainable development. Please, floor is yours. Well, thank you very much. I would like to ask if you can see my presentation. Yeah, we can see it perfectly well. Thank you very much, the organizers, for the invitation and possibility to be here and talk to you. And the central thesis of my presentation is a new tendency in a global agenda for decarbonization. And this is a tendency which is about if up to very last time the main actors were national states regulators, and for the last 2.5 years markets not just started changing, but the market players, oil and gas companies, and the financial institutions, different exchanges, different trading sites, and they not just started actively involve themselves into the practical steps of decarbonization, but they also propose quite workable algorithms and approaches to which begin changing the work of the global markets of oil and original markets of the oil and gas. And of course, we are in the beginning of these markets, but it's very interesting from the scientific viewpoint, and it's very important from the practical viewpoint. And it's important for us to understand these tendencies, to evaluate these tendencies, and understand the challenges which we probably will come across in our oil and gas companies in Russia and in the Russian economy in general. I will be talking about two new segments in the global oil trade and in regional trade of gas trade. If we talk about oil, so for a long time, two key characteristic of oil have been its density and additives. And now we have one more parameter. It's carbon capacity or carbon intensity. And so this volume of carbon and greenhouse gases which are emitted during the oil value-added chain in oil industry from production to the final usage and as a motor fuel. And what is important, and this characteristic is carbon intensity. Carbon intensity, oil produced in different countries and different oil fields, it has quite a different parameter in terms of carbon efficiency, carbon intensity. On this slide, you see the relative carbon intensity per oil unit compared to Saudi Arabia indicators, which is accepted as 100%. So as you see from the viewpoint of this characteristic of the carbon intensity, Venezuela, Canada, and some other countries, it's a quite different goods. And the issue is how quickly a market will take it into account and how quickly and how soon it will become important. I think it will happen very, very soon. And why I think so is because from July last year, the biggest world business information aggregator, Standard & Poor's Global, who acquired Platts agency and recently acquired IHS. They published monthly statistics about carbon intensity on the biggest oil fields in different countries. In North America, in Africa, in the Middle East, and even in the Central Asia. And nowadays, this kind of information regularly is published in about more than 100 oil fields in the world. From the technical viewpoint, that means that there's oil wells which are identified, and they have this microelectronic system for oil monitoring and its quality. And they also monitor and follow these parameters as carbon capacity or carbon intensity. And so this is the new characteristic which is used and followed in the oil industry. It's important to understand one important point, that from this summer this year, the list of Standard & Poor's global list of oil fields which they monitor, they included all sorts of oil which are in this list. So, of course, it must simplify for future and for the marketplace, for the financial place, the launch of new contracts for oil, which will take into account such a parameter as oil carbon capacity. It's important that in standard information about the biggest oil depots, Standard & Poor's Global publishes information for the price brackets and the market of the carbon units, which work for different markets, for different industries. So when you buy this oil, you can obtain the carbon neutrality of your oil. And I believe that during 3 or 5 years, the global oil market, we will have the separate segment of oil and gas Well, that means that the countries, and first of all, the Persian Gulf countries will get additional competitive advantage as opposed to oil, which is produced in North America and Latin America. So this is important, and probably market of sustainable gas is developing faster. The sustainable gas, it's a gas which is certified and verified in terms of the methane emission. And now about 15% of American oil and gas industry, they have microchips, and they have special equipment which in real time allows to get characteristics of this gas, and global financial institutes inform all the market participants. And some sites which specializes on oil trade, and they specialize on decarbonized products. They already launched the first contracts on this sustainable gas.
And even more, so if we look at the prospects and the speed for the development of the sustainable gas market, there are two things to mention. First is that all largest European companies producing electricity or distributing electricity between final consumers have already signed pilot contracts on sustainable gas with largest producers of this gas, Northern America, US mainly, including BP, which means that sometime soon we might see a synergistic confluence of such mechanism as certified sustainable gas, certified methane, as well as such as CBM, which is Trans-Border Carbon Regulation, which is being promoted by European Union despite all the current challenges. Another element is that this initiative is being promoted not only at the level of regulators and largest Western companies, but also at the levels of various partnerships and regulation and associations and regulations, where including Qatar, even though you cannot be looking at them as super majors producing oil, but Qatar has officially declared that by 2030 it would reach full methane neutrality, which means that Qatari gas would be rapidly certified by methane, and that way it would be reaching not only the European markets but also Asian markets. And thus the trends that are developing at the crossroads of European American markets seems to have quite a good international character and can relatively quickly come into the Asian markets as well. And in this regard, as mentioned by many previous speakers, we start looking at the question of risks brought on by the processes of segmentation of the global trade by different types of gas, sustainable gas, etc. globally, and what are the risks for Russian companies? Well, a view from the point of view of businesses allow us, I believe, to see the risks of decarbonization, demethanization much better, because it's not just ideology, it's not just a policy of state regulators. Large and greatest players of be it real sector, be it financial sector, be it all other supporting sectors, have seen opportunity of becoming much stronger, becoming much more attractive, and get greater market share than other competitors by using various algorithms, and that way grab a bigger share of the market. And this process we see starts bringing the benefits to market participants. And once it gets there, it becomes irreversible. And it's clear that the global oil and gas leaders have very powerful both organizational and financial resources. They have been digitalized long since, because you understand that the process of decarbonization is impossible without very wide and deep work with application of digital solutions. So the leaders are looking at other ways of strengthening their market positions, which brings the risks to all other oil and gas companies, especially for oil and gas companies that are working with low intensity natural gas or not certified, or not sustainable, not methane certified. Russian companies are seeing these risks. They are looking at ways to mitigate respective risks, and in case of Russian companies, respective risks are being further complicated by economic sanction warfare we are witnessing from the spring of the current year. Well, what's next? How can our companies work with these risks? Well, the evident thing is that we need to understand the main trends of this transformation of the global commodity markets, and that is first and foremost necessary, because earlier or later it would come back to normalcy. Our companies will get a chance to work in standard market conditions just like other market players, and by then we will need to develop a tool set and methodological solutions, and otherwise be ready to work effectively on a new landscape of the gas market that would be working in line with the decarbonization requirements. In this sense, it's not only the companies but also state regulators should be ready. And the most important thing is that Russia has very strong positive factors, the levers that allow for a proper response to respective challenges, build long-term development strategies, which means that in this current, quite a challenging economic period, that would would be quite extended or some quite time. It should not be lost for building various market-based solutions, decarbonization solutions that can be implemented, relying on Russian both natural as well as informational resources. I would allow myself to finish here. Thank you very much for your attention. Be ready to respond, but also organizational, and we would have one now. With all my due dedication, engagement for the oil and gas industry, I have filmed a number of movies, even though being an amateur. I would like you to continue quite a substantive discussion here, and in this sense, we would have a chance to get support in here in the Academician of Russian Academy of Science, Valery Kryukov. Let us welcome him as my replacement. Gennady Iosifovich, Mr. Shmale, it was a pleasure to sit by your side and take part in this conference. And meanwhile, I would like to introduce the next presenter, Alexei Stepanov, Institute of the Gubkin Institute of Oil and Gas Problems for Russian Academy of Sciences. The topic is energy security of Russia in the period of geopolitical and economic uncertainty, very much in line with the current situations. Alexei Mikhailovich, you go, it's 10 minutes. I've taken a look. We have 10 presentations and 2.5 hours to go. And in the interest of getting everybody heard and have some time for Q&A, it would be important to follow the time frame. All presentations are very interesting. Alexei Mikhailovich, the floor is yours. Hear me? We do. Thank you very much. It's not very honest to cut our presentation time at the last moment, and it would clear it's honestly not very comfortable to be speaking in front of a semi-empty hall. In my presentation, I will stop on a number of topics. The main specifics of the current stage of the global transformation. And before we analyze these, I would like to say a few words. The first challenge problems of energy security were faced by the global economy as a result of Middle Eastern crisis of 1973-74. Since then, it started having greater importance in the regional policy, the national policy of the importers, as well as many other countries. At the verge of the 21st century, at the growing globalization, the energy security started having new dimension. The global dimension became one of the greatest components of the global security. In this condition, this led to understanding that the challenges of energy security is very much dependent on energy cooperation. As the International Energy Agency has formulated, energy security is not related to the lack of energy resources, but in the access to respective resources. Energy aspects are part and parcel of all the all human activities. At the same time, important market players start speaking about the... I hope you are seeing my slides. Yes, we do see the slide, but for some reason you are not advancing. Some of the global players start seeing international cooperation as unnecessary. In the second decade of current century, we started seeing speeding up transformational dimensions. That's because we are seeing deep transformation covering all aspects of life. Society in the last 2-3 years are becoming an important peak that was first we started seeing volatility of the market prices, then started having pandemics and challenges. On the other hand, the successful development of oil and gas fields, as well as working on the renewable sources that is transforming energy landscape of the world, concerns related to the changing climate lead to an overall trend which started being called energy transition. Another particularity of the modern economy is that the development is a result of diversity of factors, including political and geopolitical, not just technological ones. Majority of them are interrelated and interdependent. The process of energy discussing topics of energy security is being actively discussed in the European Union as well. Slide number 4 demonstrates that for many years energy security was concentrated on the development of internal market and energy efficiency, as well as increase of renewables, as well as diversification of energy sources. After the coup d'etat in Ukraine 2014, a new stage, European Union started speaking about first diversification of energy sources and then decreasing energy dependence from Russia. The events of the recent past, especially the last half a year, have brought more challenges and uncertainty not only for the Russian economy, which fell under the very powerful sanctions regime, but for the greatest whole of the economy. On the 23rd of May, Kristalina Georgieva of International Monetary Fund has declared that the global economy is now facing the greatest challenges from the World War II times, and that was said without keeping in mind the full refusal of consuming Russian-generated energy. In that sense, G7 country leaders are speeding up, pushing the world to the verge of the global, not just political, but also economic crisis. At the same time, over the recent decades, we've started seeing significant transformation due to the new global leaders coming up on the arena, and the international arena, and turning monopolar into multi-centric worlds. Thus, technological and other shifts were expected, so it was just a matter of the character of the shifts, because they might be taking in decades for materialization. Plus, these are very difficult to quantify. In today's growth of uncertainty and unexpected circumstances, we are just living through one more turning point. Mikhail, you have 2 minutes. then maybe I should stop whatsoever. If the topic is not interesting, then maybe I shouldn't be taking your time. Is that acceptable? We lost you. Then maybe you should see the last slide, and I will just cut my presentation short. Thank you very much. Unfortunately, we are having challenges with their connection. Alexey Mikhailovich, then the eternal Russian question, what should we do? Can you give us a short clarification? Energy security, what should we be doing this time? Unfortunately, we didn't have time to speak about this, so let us not be coming back to this. Thank you very much for your point of view, for your very dedicated position. Let me remind that Alexey Mikhailovich has a great experience of working in the Ministry of energy as well as scientific work. A person who has done a lot into assuring Russian economy sustainability. We are proceeding, dear colleagues. The next presentation is by Alexey Tudvachov. A number of aspects related to underground storage of greenhouse gases, if possible. Also 10 minutes as well. Very topic theme. Good afternoon, dear colleagues. Maybe my topic will be out of tune with the topics discussed at the conference earlier. Many are saying about transition, and we are talking about nuclear energy and low carbon trace, and we need to be speaking about the balance, just like the nuclear waste or worked out materials are, and their storage is not resolved. The same thing is true with my presentation. I'm talking about the storing of respective elements for subsoil. I believe the resource of the future is water. All the wars will be for water. We used to drink water from the tap. Now we are buying water bottles, and the experience of working with bottle is showing that the quality of water is decreasing, but the water is a strategic resource of the Russian Federation, and our objective is not to lose it.
So we're talking about the underwater solution of this problem. Of course, we can talk about some other processes, about the nuclear industry and some other technologies. So it's as we see on the slide, and it's been shown already, the emittents are not very far. They will be quite near and quite close. And it will be in the water, underground, of our greenhouse gas. And we have been working together with Rosnedra, with the government, with the different working groups from United Nations about harmonizations of our legislation according to the international norms and regulations. Of course, we have to take into account peculiarities of our legislation. And the main thing is that the level of our knowledge about the geological, hydrogeological, first of all, situation. Of course, the problem about how hermetic it is, and how it's airtight and watertight. And we're also planning to launch some pilot projects and about the pumping gas into the water layers, underground water layers, and water carrying layers. And until now, we don't have any kind of economic evaluations of the water resources are above ground and underground. We don't have it, and we also don't have the concept of water as a commercial item. And what we also have to calculate all this economically, how to protect it, how to store it, because this is market economy category. Can I have a next slide, please? The situation is as follows, and before we, well, first of all, the main collectors will be just underwater reservoirs, and we have to evaluate the underground waters and understand what kind of inventory we have now. And so you see the small little squares, and so this slide shows what we have now, and we have to have a complete inventory so that to get the big picture, and we have to understand how to use our water code in our legislation. We need additional information because we have to alleviate the risks, mitigate the risks for industrial purposes when we use this kind of water. And so we need to, the main criteria is the absence of, not to interfere, and because the lifetime of the well and the cement which is dissolves in the water, it's about 20-25 years. If you look at statistics and the reservoirs which we have, so we can see that according to the industrial categories, about 40 million we will have, and well, that means that per capita we have about 270 liters, and the production is about 73 liters, and the standard is about 100 to 400 liters a day. So this is the only guaranteed protected source of water for in case of the force majeure. And now what I want to say is that if we go further, and we have to mention the connection of the ground and underground water, surface water and underground water. And this slide is showing. And so these are the examples of the dissolved CO2, and a lot of people died in Cameroon. So this is a natural phenomenon. To avoid such technogenic catastrophes, and so this is we have to have an inventory of what we have underground, and we have to prohibit to store greenhouse gases and underground, and to prohibit to do this kind of technological operations and next to the drinking water wells. We have to be very careful because existing technologies do not provide reliable tightness of these wells, and we will develop special regulations in our federal legislation, and of course we test it on our pilot projects and not to lose our water resources which are not renewable. Well, thank you very much for your very interesting viewpoint. So, but can you comment on foreign experience in Norway, for example? Norway is our gas competitor. They had oil and gas, deposits, now gas and oil, so they were bearing a lot of CO2 in order to increase their oil production, and it didn't impact them because they synchronize it together with the fish breeding, and so they use these biological resources. It's a very interesting problem we just solved. But Norway also has experience on the shell, but our greenhouse gases are not stable, and CO2. So what can happen if they break through into the drinking water? So that is why I just propose to limit it. And in Norway, they increase the oil production. So it's a different story. Yes, that's what we're talking about. We're talking about learning more about how they interfere in different layers of water carrying areas. So it's about the accuracy of the remote investigation about these water deposits. Yes, it's on one hand you're right, but on the other hand, we all try to calculate the cost and to drill wells not so deep because it's cheaper, and how can you investigate cover and how it will work in reality. So from our experience in Krasnodar, there is the deepest wells, and they have 4 layers of water. They have clay, but our analysis shows us that they are all hydraulically connected. Well, thank you very much. Thank you very much for your. It's a warning. It's a warning. It's a red flag. It's a warning. Well, thank you very much for telling. Yes, let's give a round of applause. So the next presentation is our project in CO2, trapping it in Orenburg. Alexander Kundik. So the time is yours. 10 minutes, please. Yeah, dear colleagues. So I'll try to stay within the time limits. Well, my first part of my presentation, I will tell you about the reasons why in Gazprom Neft we started doing this thing, and it was interesting. And the second part of presentation will be about our pilot project, which we announced last year. And the climatic agenda, which we started discussing in 2020, when we got first trans-border carbon tax in European Union, so it shaped up the global market. So now we can say that about 40% on the global market is in the climate-oriented countries. In China, climate-oriented countries, these are North American and the European Union. And China last year, they implemented national system trade of emission trade, and they follow the same roadmap which European Union followed. And we expect that we have some kind of trans-border regulations where they will charge for the import of the products, import of products with a high traces of carbon trace. And for us, it's very important, of course, but we can do it if we use 3 main levers. First is using the hydrogen fuel, renewable sources, and so on. The second, it's the climate projects and the trapping capacity of wood and other vegetation. And the third, probably the CCS technologies of trapping and utilization of hydrogen, on which we have to have about 30% of all global utilization. So CCUS industry is forming now with the support of different governments. So the main player is in North America, where the stimulating mechanism of government support is the different kind of tax incentives. European Union, where we have the market mechanism, and this is China, which moves along these lines as well. If we sum up, so you understand that in the world we have more than 100 projects, out of which 40% are in North America and about 30% European Union and 25% China. So the correlation of existing and what we plan, it's pretty obvious. And Russian Federation has a unique potential of using CO2. Thanks to its geographical peculiarities, in Russia we can have some hubs. And the biggest one is probably Volga region, where we have a lot of information about the geological structure of this area and availability of emittents which are motivated to decarbonize their production. So there's the metal industry, petrochemical industry, and energy industry. And nowadays, we all know that in Russia we don't have any mechanism of monetization of such projects, and one of main stimulus can be the production of the additional oil and additional profit from additional oil production, which can be used with the CO2 technology. We had a preliminary evaluation of the potential for the additional oil production. We analyzed more than 700 oil sites, and based on this analytical survey, we built a hydrodynamical model, and the additional production was 560 million ton, or 15% increase. And in Volga-Ural area, we can place about 2.5 gigatons of CO2. And Volga-Ural province gives about 20% of all our country. And what we're talking about? We're talking about about 220 million tons every year using CO2. And so we can solve two problems: decarbonization and supporting strategic level of oil production. And of course, the volume of production of the new industry, we have to have a pilot project, serious pilot project. And we see it in Orenburg area, in which we plan to solve several technical challenges about building technologies and placing the new innovative technologies. Well, we plan to build up the system of interaction inside the team among interested parties. And the key specifics of this project is its possibility to expand it and turn it into the regional hub with a capacity of 50 million tons of CO2, which it can devour. And we included some petrochemical companies with 2 million tons emission. And as a storage facility, we plan its Orenburgsky region, which is operated by Gazprom Neft Orenburg. You have 1 minute. And the pilot project covers all production chain, and now we have product research. We attract leading institutions, and the pipeline, 75 kilometers long, will connect emittents with our geological trap, and we will continue working on this. Our model shows high energy intensity, energy output. So to get 1 ton of CO2, you have to spend 230 kilowatts energy and 2.3 pure technical water. So we understand, so with this kind of energy output, it can be realized only with the support of the government, of the state, public support, and all these calculations are based on our real research and based on our own research work, and we already have some solutions, and even we have the thermal balance for this kind of project. So yes, of course, we have some problems with the sanctions. Our equipment and our compressors, our smoke pumps, and our compressors. And as for compressors, we got confirmation from Kazan plant, but in future we hope that we will be able to prove the feasibility of our project. So who will pay for it? Now our project is ready to go to the market, and of course, as a benchmark, we look at the European market, and now we are about 54, 74 euro per 1 ton of trapped CO2.
In Europe, it's up to 80 euro cents per ton, and in Europe, and it's also a possibility of compensating related costs through the tax for extracted natural resources, alternatively other mechanisms that are worked on. All these mechanisms are being actively developed now and being approved by various ministries. Short question, you have presented the well-developed technological solution. These are solutions whenever they are being developed at the high level of maturity of technological base. There is the so-called organizational engineering for the implementation of such projects. Existing companies oftentimes are not matching the types of the economy and relationships. I hope you understand the nature of the question of mine. You would need to think through the organizational engineering, because in case of the existing companies, there is a very, very high transaction costs for implementation of the project. That's something clearly visible in companies all around the world. It's not just about the implementation of the technology, but also the principles and motives for the implementation of technology, because in regular conditions, technology usually, when it's developing, it's pushing towards lowering costs, and unless it's not doing that, that technology is not necessary. But that's more of a comment. Thank you very much for a wonderful presentation. Let us continue, dear colleagues. We are having a presentation from our colleague from China, Mr. Gao Shiseng, the experience of the low carbon development of China. Yes, the floor is yours. Thank you very much, Mr. Moderator, Mr. Chairman, Mr. Dear guests. Good afternoon. It's a great honor to be representing the Embassy of China in the Russian Federation at this forum and use this opportunity to talk about Chinese practice of low-carbon development and the future in the policy of petrochemical industry. Chinese petrochemical industry is taking an important place in the national economy and in the low-carbon development. In 2021, the number of large Chinese enterprises of oil and petrochemical and chemical industry amounted to about 27,000. The overall operational income of the industry amounted to 14.45 trillion yuan, and the profits for the first time was over a trillion, reaching 1.16. Petrochemical industry is one of the 6 main industries with high energy capacity and high exhaust of CO2. In the future, petrochemical industry of China would face 2 challenges. One is the problem of the need for the development, and as well as the need for decrease carbon exhaust. On one side, the objective of China in the peak of the exhaust of the CO2 and carbon neutrality is clear, and the state is taking everything possible for the achievement of the peak of the CO2 emissions and carbon neutrality. Is an industry with high level of emissions of CO2. Petrochemical industry is feeling acute need for the achievement of green and low carbon development. On the other hand, the development of the economy and change in the market demand, the need for chemicals as well as new materials would be growing, incentivizing growth of the industrial capacity and respectively increasing emissions. We need to correct the structure of the industry and stress competitiveness of the industry, stressing the petrochemical development from the speeding up development of petrochemistry from oil and gas as a raw material to the development of industry, fine chemistry. The concentration would increase, the capacity would be operating at over 80%. We need to continuously stress the development of project petrochemistry to increase the petrochemical industry, as well as to continue developing the value chain of petrochemical industry, increase the ability of supplying high-quality polymers and specialized products. Keep an eye on new production capacity in such industries as petrochemistry, production of phosphate, ammonium phosphate, ammonium carbide, and yellow sulfur. Forbid the production of polyvinyl chloride to the use of lead and speed replacement of low effectiveness and outputs. We need to promote petrochemical industry development towards the use of advanced applied technologies for the modernization in this security, as the olefin and the aromatic, as well as including the use of C5 and C9, and the reliance high-tech innovation for the development of environmentally pure and low-carbon development of the industry. By 2025, the share of investment into R&D from the income of main businesses and large enterprises would reach over 1.5%, implemented over 20 key universal technologies and over 40 key new products. The level of automatic operation of the main industrial equipment in the key areas of petrochemistry would reach over 95%, would have over 30 demonstration factories with smart production, some 50 demonstration parks with smart chemical industry. You would need to stress the main role of enterprise innovation and promote deep integration of industry, scientific circles, research and their application. Main technologies should be mastered and stress the impulse of innovation, speed up breakthrough in new technologies such as new type catalysis, environmental synthesis, production, functional and structure, integrated polymer materials, and wide-scale use of green hydrogen. For Russia, petrochemical industry is particularly important, especially green hydrogen. We need to be using chemical projects and introduce them into industrial clusters and promote the development of the industry at high level. We need to promote concentration of new petrochemical and chemical projects and with chemical clusters with new cooperation of raw materials and environmentally clean sources of energy with high environmental sustainability in protecting environment. In the 14th 5-year cycle, we would have about 17 new chemical industrial parks with competitive advantages. By 2025, chemical cluster would be producing over 70% of the total production of the industry. Fourth, speed up environmentally clean and low carbon development. In the course of the 14th 5-year cycle, consumption of energy and CO2 emissions per unit of product would significantly decrease, and the total number of flammable organic components would decrease more than 10% compared to the 13th 5-year cycle. We need to fully use the advantages of a fixed consumption of CO to coordinate the efforts in the decreasing emissions and work overall on the increasing energy efficiency of the industry, reasonably use gas instead of coal, and continue increasing the share of raw materials rich in hydrogen, promoting petrochemical enterprises and develop green hydrogen reasonably and in line with local conditions, as well as promote demonstration of large-scale catchment storage and replacement of CO2 by oil. Petrochemical and chemical enterprises need to speed up the development of energy saving and emission decreasing methods such as cracking of raw materials to ethylene, promote regeneration and transform the chemistry. Under the personal leadership and support of the chairman Xi Jinping and the President Putin, energy cooperation became the most important and fruitful large-scale operation between China and Russia. In the 26th regular meeting of Prime Minister of China and Russia was promoted to continue developing China-Russia energy cooperation throughout the whole value chain of extraction, serving extraction, transportation, processing, wider. All this chain includes upstream, midstream, downstream petrochemical industry work, includes wide spectrum of opportunities for the development, wonderful foundation for cooperation with Tatneft was based by Shandong Jere Group, PetroChina province of Heilongjiang in Sichuan have developed good contacts with the Republic of Tatarstan. I am confident that with the support of the leaders and authorities of two countries and joint enterprises of these two countries, the Republic of Tatarstan will start taking greater place on the map of Russia-China energy cooperation, and this cooperation would come to a new level. Thank you very much.
And very well-balanced presentation. Thank you. Действительно впечатляет.
We are indeed impressed by the logic and the very well-balanced presentation covering great many aspects, with all the as well as the proposals made by our Chinese colleagues. Next presentation is Konstantin Tagirov from Tyumen, decarbonization at depleted fields, possible ways. Please, 10 minutes is yours. Hello, colleagues. It's a great pleasure to have a chance to exchange experience. Thank you very much for the presentation by one of the speakers on the experience of Gazprom in Orenburg region. We would like to now present our experience. One of the projects implemented by Rosneft. I would try to report this. Every company is familiar with ESG today. It can't be developing without it, or will, but slow. It's a fact that it's there, and it's a must, and it will be there. It was spoken about global warming, so just mentioning in passing. Russia has fourth place on emission per 2020 data. Interesting, but on not physical but per GDP, because we have confusion. People think that per unit of GDP very large. In that sense, our products is very much. And so we are having different figures. The company has a strategy and objectives through 2035, identified by ESG strategy, prevention of direct and indirect emissions, lowering intensity of direct and indirect emissions, in survey and extraction, methane and zero gas burning. One of the fields we have selected, everybody understands, we are talking about a unique field, and I guess everybody would know what we are talking about. We have selected it for the test, the work I'm presenting you, because there is proper infrastructure, many layer segment with the possibility of sequestration, availability of adjacent sources, looking to various projects, high degree of the level of extraction, so greater number of potential traps in the future, as well as flexibility for the project development in different dimensions. All stages in brief. First is CO2 catchment, the weakest stage of the process, then preparation, transportation, and utilization and use. These are the key elements of these projects. For these projects to be more viable, so that we would be able to justify it economically, we are looking at CCS, storage and utilization, looking at PNP or burning it for CO2, as well as a reverse pumping of the gas if other projects would not be reaching payback. Conceptual mechanism on CO2 catchment has been described by the previous colleagues, so won't be stopping here much. Expected capacity on CO2 catchment 480,000 per year. That's the emissions, our own emissions on the field. Plus, we need to know that we don't have domestic equipment for catching and purification of CO2. We have already mentioned this, and CO2 would be pumping underground, would be at the fluid, supercritical fluid state at our temperature and pressures. Our sources, altogether 9 million CO2 emissions from 2028 to 2050, 90% catchment efficiency. The amount from 28 through 50 is 4 million. Let me demonstrate the two main sources shown at the diagram, two flares at the moment. And then 68% of the exhaust on average on those flares, because that's exactly what we are fighting, battling, because when we are stopping our factories for repair, that's the gas that we are forced to burn, and we have to work with them. We looked at all the traps, looked at the removed reserves in various deposits, looked at the regional water-rich layers. They were excluded because these can't be utilized, and the previous presenter mentioned about the importance of water. We would be having in the future potential traps. We have 56. We are looking at their characteristics, the transit foundation and the because there's quite a lot of the so-called transit fund. We have some 20,000 closed roads, so we looked at the greatest traps that would allow us to satisfy our needs for gas sequestration. So we looked at the passport of two projects where we have looked at various distances from respective traps, from the flares, currently the sources of emissions, and have done two calculations, and we have seen negative NPV, talking about the some economics with this kind of emissions in the scenario of at 60 per ton, the project is not viable economically. Then we looked at the source providing energy station that is providing the field in the perimeter. We looked at that project, a better NPV. We see it's 14 billion rubles, but at $60 per ton, it's still doubtful. And economically, it's a very preliminary calculations show that you see the figures on my slide, and there would obviously be some corrections at legislative level, quotas, etc., etc.
But our task is to evaluate options. So can we monetize this project? So we looked at how we can use our CO2, and for these projects we prepared a review of the world publications, and both we will use it in the models and test them, and we'll just after that we'll come to conclusions what we're going to do. And of course there is the issue of corrosion of the existing equipment. And the last option, which we going to consider and implement if we fail with the other ones, even if we have, so this is the reverse pumping and drying the gas back into the reservoir, because this gas anyway will try to escape, and then it will send it to the gas processing plant. So it was the last option. Well, so what are my conclusions? So these technologies improve the ecological situation in Russia, which of course goes along with our main purposes of our company. And the project which I talk is not efficient, but the synergy with the external sources will allow us to have a positive energy balance and the possibility of generating profit using the CO2, and we plan to start the laboratory research and with this industrial testing. So, and as for the current challenges which we come across, and I think we all feel it, all of you who work with this area, and it's a development and designing our own equipment. And we have to do it, and developing of the mechanisms of the government and state support and some additional incentives or privileges, development, training specialists in this area, and we have to exchange our experience with our companies and develop the necessary legislation in this area, and the development of the detailed projects about decarbonization, some kind of standard projects and implementation of this project with the whole scope of R&D work. Well, thank you very much. What I can recommend you is that you have to calculate not only the immediate efficiency, but also social, economic efficiency. For example, so we talk about, for example, specific city and specific territory. And for example, if they have the employment issues, if you provide some kind of multiplication effect and you add extra jobs, so you decrease the load on the budgets on the flows. So using this multiplier, the project can be profitable. And then you calculate the local efficiency as a investment project. Well, I have to say that it's a big source of CO2. And I'm from Nizhny Vark, and I worked in this company for 10 years. And the biggest problem is with the plant and communication with them. It's the most difficult thing. It's an issue of the licensing policy. It's about cooperation of different companies if we work on the same field and how to organize it. Yes, I worked with the first digital model of Somatlor in 1992. Worked with the Lazar Bank and BN Abrabank, and I worked 2 years with them. There was the first digital model. So 30 years passed after that. Well, thank you very much. Yeah, good luck. Bye. We move on. We have a lot of questions. How to prepare documentation. I think that Arslan will tell us about it. What to do with the documents, so he will tell us about it. Yes, so 10 minutes. Good afternoon, dear colleagues, and we would like to tell you about some aspects of preparing the project documentation. Spymaster's preparation of project documentation for the purpose of placing carbon dioxide in rock layers. But first, I would like to tell you that the preparation of the project documentation, we based our work on the government laws and regulations, which are administered tomorrow, and documentation defines all these procedures, and we're based on the Minister of Ecology, how to prepare this kind of geological investigations. Now in our country we have 17 territorial departments of expertise, and we issue from 100 to 600 expert conclusions a year. So this is some basic information. Number of pieces of documentation and the volume of this paperwork increases every year, and we work more intensively because we have more projects, and we have to give licenses to the applicants, and so that's why we get more projects. And we have also more projects in the PVS area from year to year, and other types of project documentation. But we don't have a lot of it. The next slide is that from March 2020, we got possibility to apply for expertise online through your personal account. And every year, we double this amount of paperwork. If in 2020 we had 17% of this work, and now it is about 40%. The decree of the government, which is administered tomorrow, still allows us to provide documents on hard copies. Nevertheless, we really recommend you to provide all paperwork through personal account or through the unified portal of government services, public services. And also in our 865 decree from the Ministry of Ecology, we have additional instructions about providing electronic paperwork to different ministers, and this register you have to include the information which we have, some information which you have on our official website, and this information in this register, they are open and available to anybody. So the main innovations are as following. So it's a list of these objects for expertise for the geological investigation. And we have new timelines for the expertise, new timelines for the expertise itself, and application for it. Expert conclusions are provided in soft copies signed by the experts, and if necessary, they're verified and given to the applicant in a hard copy. And we also combine Roskomnadzor considerations of the documents along the lines of the federal law. And part of this project documentation, if we drill in the Arctic zone, so you go to the expertise, and then in parallel we have geological and ecological expertise. And so we do it in order to shorten the time. So could you tell about specifics? What is the trend? What is the trend? And now we are decreasing the timelines. Now we have 60 days because of digitalizations. We decrease it from 15 to 20 days for expertise. And on this slide, so you see the main stages for this expertise. And let me just say again that the possibility for the geological investigation for CO2 and the building of such. So we have it in the legislation. So in paragraph 6, Article 7, and we also we also see that in legislation we see the possibility of building these new storages for the CO2 if you have an independent license. In the Article 22, we give a right to our clients to work with this necessary package of documentation, especially which concern the storage of the CO2, and you have to have a joint license for the carbohydrate raw materials. On the slide 12, you see the content of the experts' recommendations for the CO2 deposits, which were approved by the NTS and were sent for consideration in Rosnedra office. And in these documents there are general recommendations. And the resume, please, you have 2 minutes. And we recommend, when you start these projects, to consider such aspects as special research with this seismic 3D research, also drilling the minimum of wells, and hydrodynamic modeling, and this stage. and our visual research, they help us to identify wells and air photography and 3D modeling, and we recommend to do it for the detailed identifications of the morphology and the geological structures of the underground reservoir, and experts must understand the behavior of CO2 in horizontal and regulations, how to work with the companies. As for the licenses, I already told you that you can get the license separate for the CO2. It's a methodical part. Do you have some kind of practice? Is it workable? How does it work? How do you acquire knowledge? So in this case, we analyzed the Russian sources and experience of foreign companies, and we developed certain experience. And in this slide, we have the men say, well, yes, thank you very much. So you have this everything. Yes, we have 2 projects already. We put them through expertise in Tumen and in Saratov and Volga region as well. Well, thank you very much. Thank you. I understand everything. You run out of time. Well, you added up the previous presentations. Well, thank you very much for your attention. And, well, thank you. We move on. So the question of the feasibility of creating hydrogen, solar, and wind energy in Moscow. So, Gennady, please talk about your input and what your input into this. So would you please return slide or the laser pointer? 10 minutes, please. Well, nowadays we are very much concerned about the rise of the temperature and climate change and some other catastrophes which we might face. So on this slide, we see the changes of the average temperatures. So I show this slide first time. And for 160 years, temperature increase 0.65 and lower is the CO2 concentration changes for 160 years to 2022, and the change happened of 46%. When scientists look at this graph, they understand that CO2 leads to increase of the temperature. So what I want to change the stimulus and response. I want to swap them. And so the explanation is very simple. Most part of Earth is water surface, rivers, oceans, and seas, and they have a lot of CO2. And if I heat water, so CO2 is emitted. So if you understand, if I heat water from 0 to 20, the concentration of CO2 decreases in 2 times. So I would explain it with this thing, with this. But nobody considered this analysis. And this is the hypothesis, the CO2 influences on the temperature. And this hypothesis is considered as internationally accepted. This is a hypothesis, but nobody considered the diagram of the primary energy, and the primary energy grew consumption 40 times. Okay, all right. I'm happy that, but I never heard about them here. And in the lower part, you see the dependence on the CO2 to the consumption of the primary energy. And we see that this asymptotically goes to zero. So that means that not carbon energy is the reason of the high concentration of CO2 in the atmosphere, but the heating of our atmosphere of this technological equipment. And the proof of this is not CO2 is the reason. This graph, this is from our foreign colleagues' publication. The green is average global concentration. And this is the sea, and this is the ground. So, and as you see, 1966, 1990, and the water temperature is going up. And with the 11 years, we see that the concentration of CO2 is increasing. So there is a CO2 concentration depend on the near ground layer of air above the ocean surface. So this is the proof of that. So CO2 is not a reason for the warming, global warming.
Together with my co-author, we tried to assess global consumption of the primary energy per 2020, and if we recalculate everything into the heat factors, time limits, that would amount to about 2,100 kilometers of heated, of melted ice. I'm just showing a piece, one of the pieces of ice. But on top of the warming up of the atmosphere with the industrial facilities, but there is also, we are also observing the change in the so-called albedo, the reflectance characteristics of the surface. And we are seeing a decrease. What does decrease of albedo means? That reflectance is decreasing. We are seeing that cloud surface is decreasing, amount of ice is decreasing. If 2/3 are coming on, reaching Earth, and then 1/3 is staying, and that 1/3 starts, and 1/3 is being reflected, and that 1/3 started decreasing. So we are seeing that the changes due to reflection is compatible to. We are seeing about the share of water, CO2, methane, and other gases in the composition of greenhouse gases. And the conclusion is that it's not the CO2. CO2 is not the reason of the warming on Earth. Thank you for being brief. Yes, you gave me, I have 5 more minutes, right? A few more words on green energy. It's meant to replace fossil fuels, hydrogen or carbons. The hydrogen, it's linked, it's fire, and it has a risk of fire as well as explosion. Let me demonstrate some elements related with the energy. This sees the useful energy generation by a hydrogen. First, it's thermal station. It's 35 pure or 65 or steam gas, and then electrolysis, we are getting hydrogen. And by using the hydrogen at fuel cells, we are getting useful power. Now, if we recalculate in black letters what we have spent, the total, and the useful capacity is 9.52 times less than that we have burned 9 times more methane than the electricity we would get after that. At the very best, it would be 2.65, which means we are losing 6 times, which means that the effectiveness of hydrogen energy is becoming doubtful. Maybe somewhere in space that could be effective, but overall, when we would burn 9 times more at thermal station, using hydrogen energy, it leads to excessive warming of global. And looking at solar panels, 13%, then the silicon panels are warming up to 40 to 45, and they're consuming energy at all frequency and all beta. So these are also serving as the atmosphere warmers, heaters. Thus, I'm not even talking about the cost. That's all having great amount of costs. So in that sense, of course, we are being offered to start working intensively these things, but our country that has natural gas and doesn't know where to sell it to, it doesn't seem very effective, reasonable either. Talking about the wind power, I had the chance to look through Cambridge University published articles that if in US thermal stations would all replaced by wind power, that would lead to increasing the temperature of the lower atmosphere level. So with the figures, and then if you make it at the level that it would be able to prevent cyclone, anti-cyclone movements, and block aerodynamic flows in nature, that might lead to serious amount of complications. So altogether, thermal energy stations are overall being more thermally efficient to prevent global warming. In that sense, we should be looking at overall figures. We should not be fighting CO2. We should be looking at the wider thermal emission into the atmosphere. Thank you very much for clear and argumentation of position. We are continuing. Next presenter is Svetlana Alexandrovna Bonanova. Priority areas for the development of the Russian oil and gas complex in the context of decarbonization and political instability. Could you please demonstrate the uniqueness of your position? And you have 10 minutes. Your time starts now. Well, first of all, I'm welcoming all those coming together. And I'm grateful to the organizing committee for the chance to speak. A year later, we are seeing that decarbonization topic is speeding up, lowering oil and gas use. Tatneft is even now moving to active use of compressed gas, and such large exporter as Gazprom is ready to start working on hydrogen consumption. And a year later, decarbonization is then being developed by various other challenges related to political instability, instability of price of oil, as well as markets to where this can be sold, supplied. At the same time, based on the Ministry of Economy forecast that oil extraction can decrease significantly, we see that in August, oil consumption and production in Russia has decreased only by 3%, and in here we are seeing serious dynamics in the industry. Meaning vertically integrated companies are not lowering oil extraction, And the net profit of Tatneft has increased in half a year by more than 50%. It was published on the website just 2 days ago. The development of the new paradigm of the development of oil and gas complex with the proposal of Academician Kantarovich, the decisions that were made last year at the conference, speeding up development, that was the speeding up the development of the oil fields of traditional oil. And a year later, in the report presented and with the recommendations on the adoption of new paradigm, we are now making we accentuating the search and the development of unique large fields, oil and gas related to sedimentary layers. Simply because in the state of instability, there is a need for new reserves related in the basins that should be brought into the development because it is seen that the discovery of new fields with large reserves is profitable. What are the natural mega reservoirs that are accumulating such rich reserves? It's actually quite a philosophical question. What are these reservoirs? And there are different classifications to the topic. And let us consider the following three positions. We believe the three following categories: traditional mega reservoirs of the gas-rich basins, which accumulate gigantic, large oil fields, and we are giving an example of Pakurskaya Svit of Western Siberia, of cinnamon sediments where these giants are concentrating in. Here I'm demonstrating a principal scheme, the structure of this reservoirs, showing the traps that are categorized by authors as part, and here a schematic map of location of the hydrocarbons. I'm showing two zones, Tengas and Yamal zones, where these large unique fields are concentrating. Detailed analysis of the composition of oils, their differences can be seen in our studies, in our work. Second position are mega reservoirs in non-traditional collectors, heavy vanadium-rich natural bitumens, often rich in other microelements. These are part of non-traditional sources, unconventional oils that are intensively being developed nowadays all over the world, demonstrating countries where heavy oils are being extracted. You very well know the case of Venezuela, Canada, with the greatest amount of heavy bitumens, tar sands are being worked on for oil. Unconventional heavy oils and bitumen resources are the results of natural degradation of the original oil, bitumen, tar sands, and natural oils. They are related to anticlines at low depths, or oftentimes related with and related to various geologic structures. Industrial reserves in Russia are assessed quite highly, as well as in Tatarstan. The great potential of natural bitumens at Permian levels at depth of up to 400-500 meters. Specific Ashalchinsky, Karmalsky, and other fields. In the scheme of work on natural bitumens, heavy oils, we see zones demonstrating the work for the geologic survey works plan to be done through 2030. Part of the Ufa Terigenic complex, the western hills, western edge of a large Tatar area, and we have also worked and prepared respective mapping in Sakha-Yakutia, preparing a map of different geologic structures and materials. Second position, giving a number of examples for comparison, tar sands in Alberta. We are showing the territories, large territories, as well as sections thereof, demonstrating that these bitumens are seeing intensive decomposition, undergoing processes of hypergenic transformation. Ecological risks have to be accounted for, and then here we are demonstrating a scheme for the development of tar sands in Canada. From the bird's eye view, from a plane, we are seeing what that surface of the area is turning into. 70 meters down, being drilled, a lot of fresh water is being used, and the oil tar sands of Canada are not just billions of barrels of oil, but a similar consumption of water. And I'd like to talk about the third position, shale formations, porous collectors, covering large territories. Shale formations have great resources and great potential, and these can also be viewed as mega reservoirs themselves. And here are demonstrating maps per Volga-Urals, and can we see some conceptualization, because the materials being presented are visible in many reference works. Well, this is clearly well-known maps, but we are demonstrating the areas, all the figures, demonstrating oil potential and calculations for 2022, and we are being stunned by the scale and comparing, for example, data for U.S. territories and Volga-Urals here. A great advantage for the development of highly viscous oils in Volga-Ural formation is the great composition of heavy metals in these hydrocarbons. This is both an advantage and a disadvantage, and there are some examples when respective industrial scale extraction of valuable metals can be extracted, thus becoming a source of respective rare earth components necessary for new technology production in various be it photovoltaics, be it windmills, wind farms, etc. Be it demonstrating the types of chemical elements and groups demonstrating, for example, in red concentrations 3 and more times higher than regular. And main conclusions we'd like to accentuate following these recommendations. In line with this instability of the day, we suspect that the main direction for the development should be looking for oil and gas in gigantic reservoirs, and we have looked at 3 positions, be it traditional collectors, unconventional collectors that are accumulating vanadium-rich natural bitumens, and unconventional low-porous shale formations. We are demonstrating the work and recommendations of how to increase the works and the complex approach to the development of shale formations, bitumen fields as a source of hydrocarbons. I guess it sounds more like a presentation for the scholarly committee about what you would be studying in your research institute. And then I'm showing positive factors, quantitative characteristics of hydrocarbon accumulation, total assessment for dynamic processes responsible for the development of the reservoirs themselves.
And you can compare the data for rich and resource-rich and resource-poor regions. Well, thank you very much for this multifaceted presentation. I think that this presentation covered very challenging area. And in Russia, in oil and gas industry, we have a lot of resources, but we have less and less reservoirs and resources. This is a category which is connected with economy and technology. If you don't have economy and technology, it's just resources. And when we talk about Yakutia, one specialist said that we have trillion tons of resources. We have to make decisions between resources and deposits because economically they're just not feasible. And we have these mega structures, and we don't have any objects to work, because if we start working on these deposits, we can learn approximately only when you begin the digitalization. So Nikolai Yeremin, 10 minutes, please. It's your main approach, because the digitalization of oil and gas is very difficult area. So, dear colleagues, let me thank you for possibility to be here, and I would like to thank Tatarstan and Tatneft company for the good organization of this forum. And yesterday we celebrated Tatarstan holiday, just a wonderful. And you were head of delegation in CIS forum in Bishkek, and using this possibility to be here, and we have President of Kyrgyzia Republic, Askar Akayev, and I would like also to thank him on behalf of our delegation for the wonderful reception in Bishkek, wonderful people, and a wonderful possibility to be on a Sekul. And it's again about decarbonization drew our attention because the air is getting worse. And it turned out that now the equation, all leading countries pay attention to the fresh water, because fresh water just 2.6% all fresh water is in the glaciers and in Antarctica and Antarctica. And this decarbonization, so the oil and gas prices grow to $3,000. Oil will probably be $300. And so can you imagine that the 1 cubic meter of water will be $300? And Issyk-Kul, Baikal, and one of my colleagues today is with Norwegians. They prepared 2 PhD theses. Is the idea the glaciers pull to the shorelines and melt them and using the infrastructure for oil and gas, transport water instead of oil and gas, because it's a big deficit of fresh water. So thank you very much again for your people of your country for this reception. And I'm also deputy chairman of the Forum for the New Technologies and the 24th Oil and Gas Congress, which will be in 2023. I would like to invite you to take part in this forum in this Canada. And it will be in Kazakhstan, the 7th Global Congress of young specialists. So please, young people, go and there and come take part in this Congress. And just yesterday, we got a government decree that that all regional powers should pay more attention to science. So now every region will have to report about 53 main indicators. That's what they do in the decarbonization, but also digitalization and using the information technologies. And I would like to again pay your attention to that. Yes, digitalization is going very quickly, and I started doing it. And 20 years ago, I started doing these things in 2002, and what we have now is in 2020, academician Dmitrievsky and I, we started this evaluation. We had about 100, and by 2025, we expect to have 300 digital deposits. And what digitalization gives us? Yes, the digitalization accelerates the development of the countries, and it, of course, alarms our partners. And of course, the decarbonization issue from the viewpoint of decreasing the tempo of development for our countries. And we are preparing now a very interesting article on how digital shale revolution impacts the strategic oil reserve. And President Biden, 1 billion barrels of oil is spent on oil in order to restrict Russia. Doesn't work. Why? Well, the strategic reserve are in the salt domes, so they destruct the Earth surface caves, and according to the 17 national laboratories which are working in the use, in the 2025 they must be closed. So probably we're using this situation. America tries to get rid of strategic oil reserve, but at the same time, the digital shale revolution, the oil drilling can be accomplished in just 4 days for 1,000 meters. And this is a result of digitalization. And what it allowed us, if For us, it's a Malevich black square. What processes are going on in the deposit nobody knew about. So digital cell revolution developed a number of new technologies which we use, including visualization of these processes. And we have nanoseismological monitoring, and this is it's like it's a seismologic monitoring allows us to hear these processes which are going on in the deposit, and we see what's going on with the structure, how oil is replaced by water, and it allows us to visualize it and to find the most interesting, the sweet spots in there. And yeah, but so now technology, and that's our technologies we created, so highly technological methods. And if you look at the United States experience, so they're coming back to this, the number of their sweet spots is going down, and even new wells don't allow them to get the results which they get 10 years ago. And our high-tech ecological technology allows us to create a system of micro-cracking, which is with a long lifetime, from 6 to 10 years. And as you see, we just like and because using the hydrocracking, we can revive these oils. And as you know, Putin pays a lot of attention to the lycanthropy and which President gave to Minister of Energy. We prepared the complete cycle of this digital modernization of the West Siberian deposit, and we invited 53 organizations of Russian Academy of Science. The proposals were included. We got proposals from all oil and gas companies, and based on this joint proposals, we just prepared 268 proposals, just turned into the very powerful concept. And for every company, they have their separate project. And of course, support of the regions is very important. We are ready to prepare and be ready to work with this program, several $1 billion with. And what digitalization gives us, if you look at this slide, you can see that 40 years ago, when there was an oil crisis, when Arabs stopped exporting oil, and the U.S. government issued a secret order for the national laboratories to create technologies which would provide independence of United States from oil export. And beginning from 2014 and 2022, we see the results of this shale revolution. So they try to do. Upper slide, it's a graph of the Restart Energy company. Of course, they using these results. Americans plan to change global oil market didn't work. Why? COVID in 2019, and the United States oil production had to be more than Russia and Saudi Arabia. This is the issue of the government and state security, but the COVID bankrupted a lot of American companies, and so all this technology. We see what happened in the oil market and what happened with the oil growth. We have 1 minute, so we companies. So we see that Americans try to change global gas market, and the gas price 10 times more than the internal gas in America. They sell gas, but I can assure you nothing will work, because there is gas transportation system which allows us to pump gas into the prices which are lower than American prices. These are technologies which we had, and the digital noise monitoring system, the intellectual system of which safety system for the land and ocean. And in 2010 there was a catastrophe in Mexican Gulf. You remember this, and it's very important when we drill in Arctic area. And I would like to mention that this project which we had together with Velikhov, I was head of this project, and this is the only oil deposit which works, and the efficiency is about 3,000 tons with the Russian pumps. So let me finish. What deposits, from the viewpoint of digitalization, is the role model which we can use as an example, as a showcase in Russia or outside of Russia? In Russia, it's Gazpromneft and Rosneft. I think Priopskaya probably. Okay, thank you very much. I will give you a medal, 300 years of Russian oil. And I would like to show this slide. Start Energy. They have 360 people. 12 years ago, they had 8 people. What they do? They analyze statistical data. There are people who collect data. There are people who verify this data, and those who build database. This company has leading global companies as clients, and Liquid System is a purely digital analytical company with an office in Oslo, and they have distributed offices in Australia, Latin America. In Russia, we need such integrator, so it's a key issue in energy and energy independence and sovereignty, and using technologies such as blockchain, big data, and so on, because we don't have communication lines, we don't have integration communication lines between different elements of this industry. It's very, very important, Gennady Osifovich. So maybe you can do it and digitalize the initial stage and of this integration approach, and we're getting data and we get new high quality knowledge. So the world is going along these lines, not just copying some engineering achievements, but we use big data, the knowledge management or artificial intelligence. It's very important. And now the next presentation is Ekaterina Kotikova, chief analyst from, yes, your time.
Good afternoon, dear participants of the forum. I'm grateful for the chance to speak here today. And I'm representing Inter-Industry Expert Analytical Center. Happy to present on the topic, modernization of absorption purification methods by increasing the efficiency of flow control. Very topical because oil continues being the main source of raw material that is contributing to economic activity. At the same time, we are seeing decrease in extraction of oil, but at the same time, when capacity is being decreased, the industry is forced to improve the quality of purification of oil and oil products, decreasing the degree of disposition of equipment, as well as the character of activities. We are demonstrating the following information on the slide. The most important being the fact that we are decomposing the original product, which is oil, into components without even speaking about high costs and energy requirements. There are at the same time alternative methods that allow us to decompose respective components without similar cost: extraction, acid, base destruction, and absorption. The only drawback is periodicity of the process. At the same time, there are technologies that can help us overcome respective projects, which is why this technology is done at the framework of smart agro containers, which is why we are developing the smart absorption process. Uninterrupted, more effective by means of the flow energy and flow control. We have broken down this work into a number of elements. One state is that we can be indeed controlling our absorbent, and second, the proper selection of necessary compositions. We are consulting with the specialists here, and at the moment we have concentrated on metals extraction, and the third dimension is synthesis of various sorbents. On the slides here demonstrating the task of our study. I'd like to draw your attention to the fact that an advantage of the method is similar to a very well studied method of adsorption purification. We are offering to modify the sorbent by introducing a steam steam magnetic component that would allow us to manage a respective sorbent at the following stages. Right now, we are at the stage of proving controllability of the sorbent. As a standard material, we are using polymeric sorbent because many other sorbents are allowing us to absorb various components of oil. In the first case, in the first part of the experiment, we were adding paramagnetics, the paramagnetic of samari cobalt, samari and cobalt, and we that way have obtained two types of sorbents that were later compared with one another. The second stage, we were introducing functional groups that were promoting the development of the metal ions for the process of chemical adsorption, which is a priori more selective. We have concentrated ourselves at imine dentary acid, and selection was based on the dentality. After post modification of the sorbent and moved on to sorbent management work, we moved on to sorbent control work. In the process, we've developed a number of lab stands demonstrating on one of these on the slide. The scheme was produced with electromagnet, which was controlled a periodic control magnet, variable magnet, and right now, and demonstrating it here, now looking at the permanent magnet and showing you a number of schemes. At first, scheme demonstrating results of magnetite, and on the slide we are showing you that samari cobalt is more effective, and the optimal mass component is consisting of 6%. The second stage of experiments was directed at control effectiveness of samari cobalt sorbent in counterflow. And on graph 3, results show quite a sustainable trend. On top of lab studies, we have developed drawing development of the of respective solutions in industrial scales. This is in case of sorbents, we are doing that at magnetic field separator. The use of magnetic field and the respective and its influence of sorbent, we are seeing respective movement in the sorbent, and the sorbent particles are taking place closer to magnetic walls of the pipeline that can be much simpler to remove it. If part of the adsorbent was not removed, we are removing them with magnetic fields. And for the depth, it's important and we are using cascade technology. The technology is interesting that inside the industrial pipelines can be used at pipelines, pumping from one reservoir to the other, but yet this is incomplete technology. Now, talking about the advantages of the developed technology, our team speaks about aselectivity of the process, high speed due to the fact that it's taking place in the flow, and thus brings in other advantages. And on the right side of the slide, I'm demonstrating a wide spectrum of applicability of the technology on top of the demetallization that we have described earlier. Many of the opportunities for application are making a great contribution in decarbonization process. Speaking about economic effect, it is mainly materializing in the price difference per purified and unpurified oil. That's in cents per, but then overall it's in millions of rubles, and this leads to supplementary profits, and that can be demonstrated on the sale of income from the sale of extracted rare metals in millions of rubles at the scale of Poltatneft. Obviously, if we look at the level of the country, 50% of the deficit of the rare earth metals that are now being imported can be covered with the local supplied local extraction. With cascade construction, the cost of the equipment with the amount of inflation of the amount 19 million rubles, they would need 14 for Poltatneft, with the total price of over over a trillion rubles. On top of that, we would have exploitation costs, and then we subtract those, and we are getting our total income. And we see that with the standard costs, we see that this technology would pay back over the course of 2 years after implementation. This allows us to conclude that this technology that is being actively developed now is quite prospective, and the research conducted demonstrates its practical implementability. This technology has a number of significant advantages over traditional adsorption and traditional destructive methods that allows us to overcome the challenges we are seeing when increasing the capacity, as well as lowering the consumption of expensive materials such as catalyzers, plus positive both ecologic and economic effect. Thank you very much. We are wishing the best results to you, and your technology have demonstrated the effect. The most important that you now managed to show the effectiveness to those who would be willing to sponsor. And next presenter would be Mr. Korotchenko Andrei Nikolaevich, presenting on the aspects of decarbonization in the field of oil service hardware and methodological complex for modeling and monitoring the process of well closure and development. Very important topics being discussed today. We are reporting at Gazprom Supplier Day. We were reporting right now we are seeing the demand not only in developing something, supplying something, producing something. The strategic task for 30 to 40 years is making sure that the country is supplied by the resources at competitive levels. And the most important component for this nowadays is oil service, developing the technology, developing the independence of the various imported equipment and technologies. All of that would give great advantages at oil resource supply markets globally. At the moment, we see that for quite a stable period of time, we are seeing stable growth in the increase of the so-called oil services, drilling wells and repairing wells. The drilling wells is becoming more complicated with horizontal hydrocracking and other technologies in lion's share as of today. Until the recent years, the share of that market was taken by foreign oil service companies. we understand that we would either be living the vacuum of oil servicing technologies, and that would need to be replaced. What do we have nowadays? Some companies are either affiliated of companies of the extracting company, which leads to bureaucratization of their development, and the growth is too slow. Not enough to replace effectively what we would be losing today. What is being done to address the current situation? Obviously, the costs would be optimized, the costs would be increasing, and oil and gas extracting companies obviously would have to think about the possible challenges nowadays. The figures I'm demonstrating are speaking for themselves. We are observing the growth on all indicators. This growth is not only in absolute but also in relative figures. We are seeing that the Western Siberia is demonstrating growth again. There we were seeing expectations that extraction would be increasing, but we see there are new growing trends. Well, what are we expected to do in this regard? I believe that in here we should look at the best practices abroad. We can take a look at upstream segment, looking at the example of the Western companies. The market is very well structured. The success of the oil service companies, vertical integration is organizing for ASAP communication, unity of business processes, optimal costs, and ASAP feedback between various operators of subsoil resources. In Russia, we are seeing the opposite trend. The market is very much disintegrated and chaotic. The subsoil users only start developing long-term contracts. For example, my company has just received a 5-year contract, which is giving an opportunity for you to concentrate on technology. Earlier, we were living on a year-by-year contract. You were having many risks when you could lose the contract and you would be unable to pay back, get the paybacks for the investment you made, and the short term was obviously not promoting investment into new technology development, and everybody was just working in a reacting mode, and oftentimes machine builders and various institutions are facing delays in payments, and that leads to cash flow problems and complicating that throughout the industrial economy. That leads to complications. The lack of horizontal and vertical integration is complicated by tender-based approach. In that case, the only indicator is everybody starts playing by price, which leads to lowering of investment into the development of labor and technology effectiveness overall. As of today, we are having a good example of Shell company, which has organized a long-term contractual basis, developing own logistics chains. Nowadays, it's not a company is a winner. Obviously, price is an important factor, but it's logistic chains that are a winning factor. Those whose value creation chains are faster and more effective, those end up being the leaders of the market. In that sense, a prerequisite for sustainable projects would be the challenges at the market with the decreasing the number of players at the market. So the main message of mine is that at least 5-year contracts is an important tool that would allow for sustainability of the market operations. And maybe I'd like to use the time I have left to speak about the oil service and contracts of our company for the wells that we are doing beginning 2004.
So what kind of service is it, this controlled muffling? And during these years, we had years when we did about 8,000 wells a year, and these are horizontal wells after the hydrocracking, the gas wells, and so different wells which very difficult, complicated geologically and technologically, without circulation, not hermetic, and sometimes even in a very alarming state. And we have a lot of experience of closing these wells, because closing the well is very often impacts on the further work of this. And now we have the 33% efficiency, and when the well loses productivity, when we close it, and sometimes it doesn't matter how long it will be repaired, it's important how it was closed. And it's very important to pay attention to details and how it is closed. And we are on the world level. Well, sometimes we recover about 50% of oil. Of course, it's a very difficult procedure. And the creation of such integrated projects as we do, what we did is we got the long-term contracts, and we participated in one of the programs with the Ministry of Trade, the system of the intellectual management. And what we did is that we got the financial support and co-financing about 30%. And what we create technologies which this visualization and automation of all technological processes, and software, for example, for the closing. It's about 40 million, but we have already some meeting with professionals. We have to develop our own software. And now we create a new technology. And our experts write in the two directions, so technology and closing the liquid wells. So we have all necessary expertise and knowledge, but the second direction, technology, it's new for us. We're creating this technology, and we're talking about decarbonization. What we create in Ministry of Trade, that's exactly emission-free project, and it's important to that we have this principle, and we use this approach, and it provides us with the solution for these technological challenges. And And this way, of course, we have the direct contracts, long-term contracts, and which allow us to solve this issue. And on these slides, we see the level of depth with which we tackle these issues, and we already signed contracts for the pilot projects, testing, and we have foreign programs, and and Schlumberger uses this, and this is the import replacement. We don't know all information about foreign technologies. And so it's laboratories and our chemical know-how, not just digitalization, not just intellectual management, and also materials. And we understand what you mean. What I wanted to say that we started from scratch, and when we have these technologies, it was just 2015, and my colleague was in my small office where we did it in Tumen Technical Park, and now we have about 200 people who work all over the Russia and create new technology. Well, good luck. I think your example is very interesting. Is worth learning, and good luck to your colleagues, to your business. Thank you very much. And we will finish our official program with this kind of analytical presentation about the climate changes, the paradoxes of the historical approach to the climate change. So it's my presentation. You are the climax of our crescendo of our session. Dear participants and dear organizers of the international conference, the purpose of this research is to understand the contradictions about the climate change. To identify these paradoxes, have to clarify the circumstances which shaped the agenda, and to consider the changes of the climate in modern days. So in 1970s, some scientists forecast new ice age and not global warming. In 1980s, acid rains were considered as the evil which is destroying and killing Earth, and the nitric acid and the acid rains mixed with the rain, hail, and snow. In the 90s, we were told the global warming put us on the pivoting point to catastrophe. In 2000s, the climate changes as opposed to the global warming was announced as real, and carbon was announced and proclaimed as an enemy. In 2010, we started the Earth engineering, and the new enemies appeared: the natural ecosystem, carbon, water, and sunlight. In 2019, we're preparing for the 2020s, when we are apologizing for the acid rains, and we implement plans for shading the sun with the acid. The shading of the sun is darkening the sun to spread some small particles like chalk, and these small chalk particles would cover Earth and will reflect more sunlight than we reflect now, and sun will hit Earth less. The scientists warn that this problem cannot be solved this way, and we will get accumulation of the CO2, but now with the chalk, and then we will sit in the dark greenhouse. In global initiative, because of these grim expectations, they show us the green mantra on the 17th, 2022, 17th of August. Joe Biden identified $370 million for clean energy and achieving the climatic purpose goals. So when we talk about definition of ecology, a lot of schemes are presented as green, and we think that the source of energy is not carbon, but actually the left wings very often blame carbon. They forget that the carbon is a very important part of life and the essence for the ecosystem. On the right side, they deny climate change, and they say that it's a natural cycle, and there is nothing unusual about carbon increase in the atmosphere. Both sides ignore the real science which is behind these processes, and the left and right both don't ignore that the artificial chemicals we add to all chemicals, they make this atmosphere very toxic, and the world started believing that carbon is an enemy. So we have to say that Trump epoch was the marked with unprecedented explosion of the oil and gas extraction, which led United States to energy success. Paris Agreement, climate agreement, where global warming myth was formulated by Albert Gore, led to Kyoto Agreement in 1997, and it got new threatening reality. The foundation of this climate agreement is that the main threat for the Earth is global warming. And I think that the global warming is because of greenhouse effects released by the agriculture and industry. So that is why United Nations Organization recommends decrease the emissions. And on the background of this economic and political hysteria, we forgot the main question: how realistic these threats are, which all mankind was scared by the activists. Does anthropogenic factor really impact on global warming? And what does modern science say about it? The protocol is based on the wrong statement that greenhouse gases cause a greenhouse effect and warms up Earth. Before the beginning of the 21st century, we didn't have any scientific theory for greenhouse gases and how they impact on the atmosphere. There isn't any reliable proof that the greenhouse gases impact the climate. So that is why chaotic protocol is based on just guesses. And nowadays, because of burning the natural fuel, we get about 10 billion tons of CO2, or almost 10 billion tons of pure carbon, which impacts not on its gas mix and adiabatic indicators, but it also increases the atmospheric pressure as well. These two factors work in different directions, and as a result, the average temperature of the Earth is almost not changing. And it will not change even if the concentration of CO2 increase doubles, which we expect to 2100. And European Union by 2040 plans to refuse from using oil and gas. And it's now there is a question: is green energy be able to stop the climate change? And all these arguments and all these numbers, there are a lot of misleading things. And now they say that the alternative energy is takes about 17%. But they don't talk about it. About 40% of this alternative is on burning wood and other biomaterials. And this information is given by the International Energy Agency. And you have a lot of these examples. And for example, on traditional energy supply is over, and everything is dominated by the green alternative, and we can't forget about the climate change danger. So the turbines and solar panels will be everywhere, and so how and here is the unpleasant facts. For the green supporters, apart from its traditional tasks, the current the electro stations, power stations, will get additional load to work on a green energy and to produce millions tons of steel, plastics, aluminum, lead, and other metals. These are all dirty and very energy-consuming production. Electro car on the road, yes, it is clean. Yes, and no pollution in the city. But for this cleanness in one place, you have to pay huge pollution in other places. For the scientists, it's quite clear that the production of batteries for cars harms ecology a lot. And so we're talking about millions of tons of liquid and solid poisonous wastes. So destruction of a lot of forests, deficit of water, and pollution of vast areas in Latin America, China, and Africa. So a lot of people will be surprised to understand if you want to build a computer, you will have to throw about half ton of CO2 in the atmosphere. And if we compare the data for the carbon emission for electric car and regular car, so electric car is 2 times dirtier. Now we have about 2 billion of these cars, electric cars, and even 1.5 billion. And so this transition to green energy will be just a different effect, and it will require more energy and will increase the energy pollution with the same CO2. Washington Times is writing that it's the last days of this hysteria. I think that the world forgot about global warming as well as in the beginning of February all people lost interest to pandemic outbursts. We didn't think that the energy prices these problems can be solved by decreasing the dependence on the renewable sources. When the gas price skyrocketed, Joe Biden asked OPEC to, and when the situation was complicated in winter, so they just told, so not just something with solar batteries or turbines, but liquefied natural gas. Well, I'm rounding up, and all this climatic agenda was invented by the West with one purpose only: to prevent competitors from developing traditional energy and real economy, and to make them pay the carbon tax to the West.
We can approach this task in the following manner. We can build and start selling to the West great number of wind turbine, photovoltaic panels, and whole lots of other things with very, very rich in carbon trace, and send all the money we earn with this into modernization of Russian economy, but not paying any carbon tax. And if the West wants to buy it, let them buy it. Try build the green energy and let them look for hydrocarbons for that. It's not the West that should be dictating the rules here, but the ones that are producing energy products, and that's when everything will come to its proper place. We thank very much Lera Gazimovna for very emotional and multi-aspected presentation. Dear colleagues, we have thus exhausted our program. I would like to thank all the patient, interested, and dedicated members of our session. We have a few minutes for some comments, for some opinions that have not yet been expressed. Do you have any comments? Well, I think it was a very interesting and a diverse session. We have heard different opinions, and I believe that the conclusion is only one. We should be coming together more often to be able to hear each other and agree and find consensus in various views, and in this sense, this conference contributes greatly in our advancement on this path. Thank you very much, everybody. Thus, our plenary is over. Please remember that tomorrow